So first we're going to start with a functions and graphs. And let's just start with something fairly simple. All right. Let's just revise all your functions and what they actually mean. Okay, right. So here we go. First one is, oh, excuse me. Right, here we go. Right. Y equals mx plus c. Right. What function is this and why? What function is it and why? Right, it's linear, it's straight line. There's no square. Good, I like that. All right. Tell me, what is the exponent on the x? It's a 1, right? Now, how many x cuts does it have? 1. Coincidence? I think not. All right, so here's y equals mx plus c. Tell me, what is the effect of c? And now I want you to think carefully about this. What is the effect of c? What does c do? What does c do? What's the effect on the function? Very nice, Layla. That's the answer I'm looking for. Good. All right. Be careful about saying just shift the graph. I want to hear vertical shift. Okay. Why vertical shift? Because in grade 11 now, you also have horizontal shifts. Okay. I'm glad nobody said the y-cut. It is the y-cut. Okay. But that's not the effect of the graph. It happens to be the y-cut. Why does that happen to be the y-cut? How do we find a y-cut? Y-intercept. How do we find a y-cut? You make x0, hello, right. And if you were to make x0, then m times 0 is nothing, leaving you with c. That's why 0 and c is the y-cut. Right. What other function does this happen in? What other function also has the constant as a y-cut? There's only 2 of them. The constants aren't the y-cuts for all of them. Which one has other constant being the y-cut? Very nice. The parabola, huh? The quadratic. And again, because if you make x0, you cancel out the x squared term, the x term in the middle, and then you're left with the constant. Haha. All right. Let us have a look at now a quadratic. All right. Y equals ax squared plus bx plus c. Right. In all its glory. What do we do with this? Right. First of all, let's have a look at a function. Right. Let's say I said y equals x squared minus 2x minus 8. Great. Right. I want you to factorize this. Right. Factorize it. Okay. You got it. X next. And then I've got minus 4 and positive 2. Okay. Everybody happy with that? Good. Now, here's the other, so we have y equals ax squared plus bx plus c, which is the general formula for a quadratic. How many x cuts does a quadratic have? 2. Why? Because it is squared. So now we have 2 x cuts. Next year, when you do cubic functions, you will have 3 x cuts. That's fun to look forward to. Anyway, so here's now the other quadratic formula is that I take out a as a common factor. In this case, it was 1. So I take out the common factor and I'm left with x minus x1 and x minus x2. Great. Tell me, what are these 1 and 2 things? They're your x cuts, right? Why are they your x cuts? Because now I make y 0 and I've got a quadratic equation. That's why you need to be good at your algebra. And now you can back solve that x would be positive 4 and y, the other x would be negative 2. Okay, great. Who can tell me now, what is this formula? What is this? Good. Right? Your turning point formula. And this is now the thing about a parabola, okay? And from here on out, any function. You only need 3 things for a function. Now, I know that your teachers teach like 9 different things. You got the shape and the this and the that. I promise you now, it's all going to be nonsense just now. Anyway, what do you need to sketch any function? A y-cut. X cuts, if you have more than 1, and either a turning point or an asymptote. That's it, just 3 things, because the rest of the stuff is just joining the dots, and you're just going to get a graph. Anyway, we'll see what happens now. All right, your turn. I want you now to express this function over here in the form y equals ax minus p squared plus q. In essence, what am I actually asking you to find? The turning point. Okay, great. Right, you do it. I want to see how you guys do it. That's the thing. You can type in the chat column when you're done. Yeah, that was beautiful. Who's got an answer? Anybody? Ah, thank you. All right. Not the answer I got. So there are a number of ways of doing this, and that's why I'm just leaving this up to you, okay? Also not correct. All right, I'm gonna just stop it. All right, let me show you a couple of ways of doing this, okay? Oh, we're getting closer, Tandor, but still, look where the turning point is, right? The turning point has to be below the 8. So there's no ways that the turning point is going to be -7, because -7 is going to be higher up. Okay, right. Anyway, I'm glad you're getting it wrong. Let me help you get it right. Okay. So everybody's happy that there are 3 formulas. Now we just need to find out how to get those 3 formulas, okay? Obviously, if you had it in factorized form, you could multiply it out and get the standard form. And now, how do we get it into this format? Like I said, there are many ways. One of them is to complete the square. I'm not going to show you how to complete the square. I'm going to show you a much easier way of doing it, okay? I'm going to show you 2 different ways of doing it. There also, if you have those new Casio calculators where you go mode, function, then you choose the quadratic function, you just put in the coefficients and you go equals, 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 and it tells you all the x cuts, and then it will give you the coordinates of the turning point. Okay. All right. Again, Rotendo, the turning point has to be lower than -8 because the x cut is over there. All right. Anyway, enough talking. Let's have a look at this thing. All right. I'm going to show you the logical way of doing it, and then I'm going to show you where the math comes from, which is also pretty cool. Okay, watch this. What do I know about a parabola? A parabola is symmetrical about its x cuts. Now, in grade 10, all your parabolas were simply were different to 2 squares. That's why your x cuts were just inverses of each other, or additive inverses. Anyway, let's have a look here. So we agree that because this x cut on the side is 4 and the other one is -2, we know that the parabola is no longer symmetrical about the y-axis, all right? And that's why I know that the turning point is going to be lower. Now, which genius can tell me what is the value now of this axis of symmetry? What is the value? Oh, thanks, Sandra. What is the value of the axis of symmetry? Think about it. It needs to be in the middle. How do we find the middle of 2 points? Aha, there we go, geniuses. Now, I could use the midpoint theorem if I wanted to, but remember, how do you find the midpoint? Sorry, not midpoint theorem, just the midpoint formula. You just say -2 plus 4. Remember, you want the average between 2 points. So you add them and divide by 2. That's actually what the midpoint formula is, isn't it? Yeah. So anyway, so that it's going to end up giving you +1. Right, now, I know now that this x value is +1. Great. Right, because I found the middle. So now I know that the axis of symmetry is x equals 1. Fantastic. Right. Now, geniuses, if I have the x value, how will I find the y value? And this is something that my grade 12s are still struggling to do. If you have an x value, thank you, Layla. Yes, very nice, Diana. If you have one value, you have the x value. So stub it in to find the y value, because look here, if I make that a 1 and make that a 1, then you can solve for whatever y is. So that's what I'm going to do. -2, sorry about my lovely handwriting, right? So that's going to end up being -9. Yay! And now here's the formula. Y equals a bracket x minus p squared plus q. Great. The a value is the coefficient from the original function. I can see it's 1, and I'll show you how we can pick these out of more difficult ones just now. Right, so I can see the coefficient is 1. Great. Now I need x minus. Great. What is this p value over here? Sorry. The p value is now 1 squared. What is the other value? Aha, -9. And now you have completed the square. Right, so you actually don't need all those silly methods to actually complete the square. Well, silly methods. it's amazing how you actually complete the square. It's pretty cool if you actually know the theory, but like I said, it's kind of unnecessary, right? And now we have it in turning point format. All right, here's another way of doing it. What is the formula to get this p-value? There's a formula to get p. What is it? Anybody know? Oh, all right, let's be clever. Ah, very nice, Diana. Yes, that's exactly it. All right, have a look here. And this is also something pretty amazing. Right, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Great. Now, this is the quadratic equation to solving for x. If I were to sub into this equation, I would get 4 and negative 2. That's the whole point of this equation, to find x. Now, how many terms are in the quadratic formula? There must be 2. Why? Because I got 2 x cuts, right? And now, where are those 2 terms? Let's have a look. Well, there's a plus and minus sign. So first of all, I got negative b over 2a, and then plus or minus the square root of b squared minus 4ac over 2a. Great. Ha, which means now, what does this thingy mean? Well, let's sub into negative b over 2a and see what actually happens. So I'm going to take the b value, which is negative 2. So I'm going to say minus 2. Oh, sorry, I had a bit of a wobble over there. So minus 2 over 2 times 1 gives you 1. Wow. So this negative b over 2a is actually the formula for the axis of symmetry. And now that I've got that 1, so that's why I tell my students p is equal to negative b over 2a. Great. Now, once you've got the negative b over 2a, what do? Well, you sub it in. So in other words, the function of p now, in other words, if you sub in p, will give you q, because it's a pq coordinate, right? Now, I bet you're all wondering, wow, if that now is the turning point, what is all this clever business on the other side? Well, you remember what that b squared minus 4ac is? It's the nature of the roots. Gee, what are roots? Well, if this is negative b over 2a, which is the axis of symmetry, then if I sub into this business, watch this here, it's going to be amazing. If I sub into this, I promise you now, I know the answer. It's going to be the square root of 36 over 2a, right, which is 2. Great. Now, what do I know about the nature of roots? Well, what do I know about 36? It's a perfect square. Now I'm going off a bit of a tangent over here, but look at this. What is the square root of 36? 6. And what's the distance between the roots? 6. Coincidence? I think not. That's why you can use that part of the quadratic formula to determine the nature of the roots, the x cuts. Because 36 is a rational square, I know that the distance between the roots will also be rational. Amazing. Now, why do we divide it by 2? Well, the square root of 36 over 2 is going to be 3. So if I now sub into this formula altogether, I'll get 1 plus or minus 3. Right? The square root of 6 is 6 over 2 is 3. Why? And now this is x, after subbing into the formula. What is 1 plus 3? 4. What is 1 minus 3? Minus 2. And that's what the quadratic formula actually is. It's the turning point plus a distance or the turning point minus a distance. Right. So those are the ways now to find it, to express it in turning point format. Find the middle and sub it in to find Q. Okay. Very nice. Good. Moving on. Oh, I love parabolas. The gift that keeps on giving. And trigonometry. Oh, all day. All right. Let me just put some more space in here. Sorry. I look like an old person. Here we go. Insert space. There we go. All right. Here we go. All right, next one. Next one. There we go. Where am I? All right, here we go. All right. So if I have now, nice clean space to work with, y equals a times b to the x minus p plus q. Great. Where is x now? It's the exponent. So what function is it? Exponential. Yeah. All right. So have a look here. What is happening to the x in a quadratic? Well, x is squared, so we know it's going to have 2 x cuts. What do we know about a straight line? It's to the power of 1, so it's going to have 1 x cut. So whatever is happening to x is always telling us what type of function it is going to be. All right. The suspense is killing me too, I know. All right, get some space in here. All right, there you go. All right, so, can't see anything now. All right. Okay, what is the effect now of all of these things? Ooh, this is a good one. Who can tell me what is the effect of A? What does A do to the function? Nope. Kind of gradients, but I wouldn't use the word gradient. Yeah, Deanna, it would have to do with the slope, okay? Like, and whether it's increasing or decreasing. So it's either going to be a reflection or it's going to be whether it's a positive or a negative function. I'm going to show you now. Anyway, this is pretty awesome. Watch this. Yeah, exactly. All right, have a look here. Watch this. I love this. I know, I'm going to say this all day. All right, let's say for argument's sake, this is now y equals 2 to the power of x, okay? Now, the A value here is 1, okay? And that's the important thing about to remember about a exponential function is that B is always positive. You'll see that the negative is actually carried by the coefficient, okay? So let's have a look at, yeah, that's fine. So yeah, this is the same as saying 1 times 2 to the x, okay? But that's pretty redundant. Okay, what I'm going to do now is I'm going to reflect it about the y-axis. Now, this is going to be awesome. So I'm going to reflect it now about the y-axis, and it's going to look like something else. Yeah, like a 4-year-old is drawing this. Let's try again. All right, there we go. Go. All right, very nice. Okay. Tell me what has happened now to the graph. If it were very nice. Have I changed width or have I changed height? If I reflect a graph like this, what are you changing? Are you changing width or height? Right, you're just folding it over. You're changing width exactly. Now, you're changing width. If you look at the y values, here's the y values. You can see that that y value is the same as that y value. But what has changed is that the x values are now literally swapped sign. Okay, and that's what happens when you reflect about the y-axis. Is that literally the x values become negative. So if this is my graph of y equals 2 to the power of x, and I fold it like that, I'm changing width. Remember, if you look at an x and y coordinate, x is always controlling width and y is always controlling height. So if you reflect about the y-axis, you're literally changing the width. And that's why you get y equals 2 to the negative x. Let's fix my y a little bit. All right, great. Now, if you want to be extra over here, 2 to the negative x is the same as saying 2 to the minus 1 to the x, and 2 to the negative 1 is a half. Great. If that's useful. All right. Now what I'm going to do, I'm going to take the original blue graph and I'm now going to reflect it about the x-axis. Right. So now, lovely. Now I've got a graph that looks like this. So now I have y equals 2 to the x. Tell me, what happened to the graph now? If you reflect about the x-axis, all the height changes, which means now all your y values are negative. So I'm literally going to make y negative. Ha! I don't leave it like that because we always make y the subject. So y will now equal negative 2 to the power of x. And that's why you can see now that's actually the a value. The negative is held by the coefficient. Aha. See now. Very nice. Okay, and for a bonus question, I've never seen them ask this in a paper before, but let's say for argument's sake, you were asked to reflect it about both axes. Right? What will the question be? What will the answer be now? So now I'm going to do this. Okay. And now I had y equals 2 to the x. What happened? How did the blue one become the red one? Right? Good. Fold down and across. So we fold down and across. We remake y the subject, and y now will equal negative 2 to the negative x. Okay. Good. Now here's another fun one. It's not really great math, but I want to show you how it works anyway. If the coefficient is positive and the x value, then you're going to have an increasing function. All right, so you can see this blue one is increasing. Why is it increasing? It's diverging from the asymptote. You can see it's going away from the asymptote. Okay, where's the asymptote? The asymptote is on for all of the graphs, is there. You can see they're all avoiding them. Okay. Now, if I look at the black graph over here on the left, right, that's that reflection over here. Now, if I look again at the coefficient, which is there a positive, and this a negative, now I know that this black graph is going to be a decreasing function. Again, if I look at the green graph now, I've got a negative coefficient and a positive exponent, so it's going to be a decreasing function. And finally, negative, negative, positive. All right. The reason I say it's bad math is because that coefficient has nothing to do with the exponent. Nothing. They've got zero connection, okay? The only reason it is increasing is because it's been a double reflection. And the other interesting thing I want you to notice here is this negative over here. Any negative coefficient is a reflection about the x-axis because you made y negative and it's just simply transferred to the other side. That's why you have happy parabolas and sad parabolas when they're negative, because you have literally folded it. And that's why coefficients are always going to be, negative coefficients are always reflections. Okay, good. And you can use this method now for any function if they ask you to reflect it about an axis. So for example, let's just go have a look at this first one, because this will come up. Just neaten this up a little bit. Right, let's say you had this function over here, x squared minus 2x minus 8. And they ask you to reflect it now about the x-axis. So they want you to fold it down. So I know that I'm going to take the function and simply make all the y values negative. Right, that's what I'm going to do. Because if they ask me to reflect about the x-axis, I must change the height. Remake y the subject, and y will now equal negative x squared plus 2x plus 8. And now you can see that the correct shifts have changed because of the change in sign. Okay, easy. Just changing width and height, really. Okay, good. Obviously, exponential equations are going to come up in here. And all right, who can tell me what is this Q? What is Q? Lovely color. What is Q? Oh, lovely. What is the effect of Q? Good, it's the vertical shift and it is an asymptote. Okay, good. Let us now just have a look at what an asymptote actually is. Be careful, I'm going to do something your teachers have told you may never do. Don't. I know. Brace yourself. Here we go. Watch this. Okay. Right, y equals, let's make it interesting, 3 times 2 to the x minus 1 minus 9. Okay, great. Now, how do you sketch any function? X cuts, y cuts, and either a turning point or an asymptote. That is literally it, okay? Now, how? All right, first of all, how do we find x and y cuts? We make x and y 0. Is there a restriction? Let's find out, okay? Can I make x 0? Can I make x 0? That's the first thing I want to know. Can I make x 0? Is there a restriction on x? There's no restriction on x. Oh, I can make x 0. Hey, let's have a look. Y equals 3 times 2 to the 0 minus 1. And even if that minus 1 wasn't there, what is 2 to the power of 0? 1. Okay, so yes, very possible. So don't be confused with this x cut over here. There is usually math involved. All right, I would pick up a calculator for this. Right, so that's going to be 3 over 2 minus 9. Using my huge brain. Somebody just type in the chat column for me, please. 3 over 2 minus 815 over 2, negative 15 over 2. Oh, yes. Did I beat your calculator? Is that correct? Does somebody? No, yes. Okay, great. Mental math, or legend. All right, so great. So what have I got now? Okay, great. I've got an x cut, sorry, a y cut now. Why? Why is this a y cut? Because I made x 0 and y ended up being negative 15 over 2. Great. So when x is 0, y is negative 15 over 2, which is negative 7.5. Right? Great. Now, can I make y 0? Let's try and make y 0. 0 equals 3 times 2 to the x minus 1 minus 9. Okay. Oh, sorry, this goes. Now I see my math is not going to work here, guys. Hold on. Sorry. Grade 11s. Grade 12s, I would have made you do it, but anyway. All right, sorry, let's make this a 6. You'll see now why it won't work. All right, so again, help me now. I wasn't going to use my huge brain again. All right, 3 over 2 minus 12 over 2 is negative 9 over 2. Oh, yes, please. Is that okay? Okay. I saved myself. Okay, negative 9 over 2. Okay, great. Minus 6. Okay, great. Right, I want you now to solve for x. let's see if you can solve for x. So here's the equation. 0 equals 3 times 2 to the x minus 1 minus 6. I want you to solve for x. I'll give you a minute. Yeah, seems legit there, Tando. I'll have a look. All right, good. Let's have a look. So there are only two rules for equations, right? This is it. Either you use inverse operations to solve it. What does that mean? You like basically BODMAS backwards. You start with addition and subtraction, you start working your way backwards. Why? We're using inverse operations. Remember, if you want to simplify, you use, let me just write this down. BODMAS. Okay, because this is also something confusing. All right, first of all, BODMAS is the order of operations. What are operations? Well, brackets of division, multiplication, addition, subtraction. Those are things we do in math. Who can tell me what is of? I know it seems like a redundant question. Who can tell me what is of? Let me just see this quickly. Oh, good thing I'm here for you guys. All right, Layla, good. Okay, this is a very common mistake. And the reason being is because primary school teachers don't work with these kinds of numbers. So they tell you that it either means divide or multiply, like 2 of something or half of something. The reason it doesn't mean divide or multiply is because the very next two things to do are divide and multiply. So why would it go divide, multiply, you know, like it makes 0 sense, okay? Now, everybody, let's read this together. Are you ready? 2 to the power of 5. Of, right? What about this one? The square root of 5. So this O is actually exponents, okay? So, right, when you are using BODMAS or BEDMAS, you actually, when you're simplifying, that's what you do. When you are solving linear equations, or in this case, exponential equations, you are literally using inverse operations. The only other time this differs is when you're doing quadratic equations. How do you solve any quadratic equation? Let me see. How do you solve any quadratic equation? What's the rule? If it says x squared, what is the rule? Before you factorize, Layla, you are going to factorize eventually. What's the rule? If you have a quadratic, not yet else, there we go, you need to make it equal 0. So let's say you're at x squared minus 2x equals 8, right? Factorizing here is not going to help you. What's this? X minus 2 equals 8, right? Why won't this help you? What times what is 8? Well, let me write them down. 1 times 8, 2 times 4. Okay, fine. What about an 8 times 64? What about root 8 times root 8? How many products give 8? How many numbers times how many numbers will give 8? How many products do you think can give you 8 based on what I'm doing here? How many products do you think I can find to make 8? All right, I'll keep going. 1 over 4 times 32. What else can I do? Come, guys. How many of these could I do? A half times 16. How many products will equal 8? I don't know. Infinite. Infinite. I can make an infinite amount of things equal 8. Okay, that's why. Let's have a look. All right, so let's just remove this quickly. There are an infinite amount of products that can give you 8. I know 2 times 1, 1 times 8 is some of them, but there are many, many, many more products that can give you 8. So what do we do? Okay, fine. Let's make it equal 0. Why? I know I'm diverging a little bit, but let's have a look. X squared minus 2x minus 8 equals 0. Okay, now we factorize it. And again, I want to know why, but I'm going to show you why anyway. X plus 2 equals 0. Right. Now, the first thing I want to tell you is that this is actually area. It's squared. And when you factorize it, that's why it's called quadratic. It's literally a rectangle with an area of x squared minus 2x minus 8. Once you factorize that rectangle, you get length times breadth. That's why it's called a quadratic equation, okay? Now, why do we make it equal 0? What times what is 0? Anything times 0. When? Always. That's why we know, okay, fine. If x minus 4 were equal to 0, then that would make x equal 4. Then that means this bracket would be 0, and 0 times anything is 0. Oh, or if the breadth was 0, in other words, the other lengths were also 0, then x would have to be minus 2. And now that's how you would get 0. Because if that bracket was 0, you definitely get 0. And that's why the rule for quadratics are always make it equal 0. Because you can definitely guarantee a product of 0. But you can't guarantee a product of anything else. Anyway, good. Yes, I know. That was for free. Okay. So if it's not quadratic, you are going to use inverse operations. What does that mean? Start with what's furthest from the x and start to narrow your way down. Great. So what is furthest from the x? The minus 6. So I'm going to add 6 to both sides. Great. Right. And you'll notice that that minus 6 is at the end of the BODMAS system, right? There it is over there, addition and subtraction. Right. Now what? What's furthest from the x now? The 3. So I'm going to divide both sides by 3 because that's what the operation is. And I end up getting 2 equals 2 to the x minus 1, right? And that's now 2 to the 1. And look what we did there. It was multiplication, so we divided, right? And now we've got exponents. Right, we can see now it's an exponential equation. What does that mean? Well, if the bases are the same, then it stands to reason that obviously the exponents must be the same. And this is what you guys like to, we drop the base and then x equals 2. Great. All right, so after all that explanation, we now have 2 and 0. Fantastic. So there's now my x cut of 2. All right, and like I said earlier, all we're going to do now is join the dots. I don't care about shape and all that kind of thing. I just want to know, join the dots. Okay. Now, there is the third thing that we mentioned earlier was the asymptote, okay? Right. Now, which value is the asymptote? We know it's the minus 6. We know this because you were told. Okay, let's find out why. Right. You are never allowed to make y the asymptote. I'm doing it. This is what I said I was going to do. Sorry, here it comes. Right. Minus 6 equals 3 times 2 to the x minus 1 minus 6. Okay, so I've made y minus 6 and the universe is still there. Okay, great. Whew. Okay, so what now? Add 6 to both sides. 0 equals 3 times 2 to the x minus 1. Divide both sides by 3. 0 divided by 3 is 0. And 0 now equals 2 to the x minus 1. Tell me, 2 to the power of what is going to be 0? Let's just pretend that minus 1 wasn't even there. Okay, so just humor me. Let's say I just had 2 to the power of x equals 0. Right? 2 to the power of what is 0? Right? There's no solution. Right? Because if 2 to the power of 0 is 1, 2 to the power of 1 is 2, and 2 to the power of negative 1 is a half. So there's no answer over here, which means there is no solution. Oh, that's why y is not allowed to be minus 6, because there's no solution when you make y minus 6, and that is why you end up with an asymptote. Now, all right. So now I'm going to go put in my asymptote of minus 6. Right. Y equals minus 6. Great. And now I need to draw the graph. How? Miss the asymptote, go through the y cut and go through the x cut. And the only possible way that this graph can work now is simply by doing this. Yeah. All right. And now we have a pretty easy. Sam, you got something to say? All right. And that's how, and now we just join the dots, right? Like you joining the dots at Spur Kitties Club with your coloring in book. All right. Everybody happy with the exponential function? X cuts, y cuts, asymptotes, you're done. All right. Next one, my favorite graph.
Sorry, sir.
Yes.
Do we only have the vertical asymptote on the exponential graph?
Well, I'm glad you asked. Let's go and find out. Right. Next formula, and this is the last graph, is y equals a over x minus p plus q. All right. So what do you think? Are we going to get another asymptote or an asymptote here? Yes. Let's just go and have a look y again. Right. So let's say for argument's sake, I now give you y equals, let's just do an easy one quickly. Y equals 2 over x plus 1. Okay. Now again, is y allowed to be the q value? Let's go and find out. Right, I'm going to make y1 equals 2 over x plus 1 minus the 1 from both sides gives me 0. Multiply both sides by x, 0 equals 2. 0 doesn't equal 2, obviously. So what does that mean? Oh, it means y can't be 1. So not equal, not equal, not equal. Sorry, so y may not equal the q value, which means y equals q is the asymptote. Okay, very nice. Okay. Now, before we get into this graph quickly, again, same rules are going to apply. The reason I love this graph so much is because the amount of restrictions. Why is there a restriction on x now? And tell me why. Is there a restriction on x and why? Why is there a restriction on x? All right, let me start with another one. Y equals 2 over x. What can x not be? Well, in this case, x cannot be 0. So tell me, in the general formula, what is x not allowed to be? Good, p. X may not equal p. Why? Because p minus p would be 0. And yes, that is a horizontal shift. So very nice. Okay, good. All right. Now, let's have a look over here quickly. In the first quadrant, I've got positive x values and positive y values. In the second quadrant, and this links to trig as well, just FYI, you've got negative x values and positive y values. Sorry, I've got my little wacom here. Right, I've got negative x values and negative y values down here, and I've got positive x values and negative y values down here. Great. So let's say, for argument's sake, I gave you the graph of, asked you to draw the graph of y equals 2 over x. I multiply both sides by x, and I get xy equals 2. Great. What times what will always give me a positive? So we know that x can't be 0, okay? And we know that y can't be 0 as well because of the asymptote. Right. What times what is always going to give you a positive? Right, good. Either a positive times a positive or a negative times a negative. Okay, good. I understand. Good. So where are x and y both positive? Well, let's go and have a look. And in the first quadrant. Right, so there you go. Or if x were negative and y were negative, or I'd end up in this quadrant. And that's why it looks like two functions, but it's the same graph. It's just because the asymptotes are making it bend away. It's saying, hey, just go somewhere else. Okay, right. Let's go and look at a negative graph now. If I had y equals negative 2 over x, again, multiply both sides by x. Now I get xy equals negative 2. Same story. When will you get a negative product? Either if x is negative and y is positive, or if x is positive and y is negative. And that's why you end up in those different quadrants for hyperbolas. All right, there's your, and again, it's a reflection, isn't it? That's what A is doing there. If you put a negative in there, it's been flipped. That's what it's actually done. Good. Okay, moving on. Now, the interesting thing, another interesting thing about a hyperbola, which you're going to be asked later, is the axis or axes of symmetry. Who can tell me, right, in this graph over here, so this, let's just work with the green one. So y equals 2 over x. What is the axis of symmetry? In fact, it is for both of them, but whatever. What is the axis of symmetry for this graph? Axes of symmetry. There's an exact equation, guys. What is the exact equation? Not the asymptotes. I want the axes of symmetry. That's what I want to know. Where are they symmetrical? So, right, good. Benati, almost there. Oof, lots of guessing out there. Let's have a look. Okay. Now, the obvious one is to see this line down here. Now, remember, there's been no shift. So the origin is right where it's supposed to be, right? And forgive my lovely straight line. Right. Who can tell me, right, this angle is 45 degrees. It's 45 degrees down at least. Who can tell me what is the equation of this line? It's 45 degrees down, passing through the origin. Very nice, Wyatt. Right, now I see a lot of theory coming through here, and that's what I'm worried about. Right, so this graph over here is simply y equals negative x, okay? the gradient of the axis of symmetry doesn't change. What does this line actually y equals negative x mean? It means if you fold it, the y values will become negative and the x and y values will switch. So for argument's sake, if you had the coordinates 2 and 3, what does it mean for y to now equal negative x? Well, it means y will now be 3 and x will now be negative 2, because you're literally going to swap the values around, okay? Right, so that's the axis of symmetry. There's been no shift, and that's why I haven't put any plus c or plus q or anything on there, okay? Good, right. Now, the other less obvious axis of symmetry is the fact that it's actually symmetrical again about itself, and that's what makes this pretty cool. It has 2 axes of symmetry. And this now is the one with the positive gradient. And that's how the question is often phrased. Determine the axis of symmetry with a positive gradient or determine the axis of symmetry with a negative gradient. And then you must just work it out from there. Now, I'm going to show you one later how we're going to do this easily without having to use these fancy theory formulas. If you know how to use those theory formulas, fine. I'm not going to because I like to do it my way. Okay, good. Moving on. So let's draw the graph now. Draw a graph. Okay, let's do that. Insert space. Okie dokie dookies. There we go. Right. Y equals. Let's go mad. Negative 2 over x plus 3. Oof, let's go bananas. Minus 4. Oof. Okay. Right. Tell me, all right, why do I love this function so much? Because we can basically draw it before we've even found anything, and then we can actually check our math afterwards. First of all, tell me, what is the equation of the horizontal asymptote? What is the equation of the horizontal asymptote? All right, so Leila, you are correct in your number, but if the question says give the equation of the horizontal asymptote, I want to see something equals something. All right, now, first of all, what does horizontal mean? The horizon, okay? Now, if it's a horizontal asymptote, it means it's controlling height. I know it seems a little bit weird to think of that as height, but remember, if it's limiting how far up and down it can go, it's definitely a y thing. So the height over here cannot be is the minus 4. So I know I'm going to come down here, and that is now the line y equals minus 4, which is now the equation of the horizontal asymptote. All right, what then is the equation of the vertical asymptote? In other words, the one controlling the width. What is x not allowed to be? Careful, Leila. Good. Right, remember, the bottom x may not be negative 3 because minus 3 plus 3 would be 0. So great, x is now not allowed to be negative 3. And that is then the equation x equals minus 3. Right. Why is that the line x equals minus 3? Just FYI. Remember, there's no gradient here. The gradient is undefined. But remember, what is the width of this line all the time? That x coordinate is minus 3, that x coordinate is minus 3, that x coordinate is minus 3. It's always minus 3. So we're just saying, okay, fine. The width is minus 3. Same thing with this y equals minus 4. The height of this line is always going to be minus 4. So we just say y is minus 4. Okay, great. Okay, good. Now, which quadrants is this thing going in? Where am I drawing this graph? Good. Right. Why? Because I can see the A value is negative. So there's been a reflection. So I know it's going in quadrant 2 and 4. So here we go. Ouch. That's not very nice. Okay. And again, what is the plan? Miss the asymptote in the right quadrants. Great. Oh, what did look here? I got a y cut here and I got an x cut here. Do I need to work those out? Yes. How do you sketch any function? X cuts, y cuts, and either asymptotes or turning points. That's it. And just join the dots. All right. So all right. I want you to find me the x and the y cuts. All right. So let's start with the y cut, always the easy-ish one. Right. A lot less work. Right. How do you find a y cut? We make x 0. I want you to watch how I make x 0. Ta-da! If x is 0, it's gone. Why am I being so proud of myself like this? I want to show you why. Let's say, for argument's sake, you are trying to solve some kind of unknown here. Okay. Let's say you had y equals a, x minus 4, and x plus 2. x plus 2. Okay. Let's say you're trying to solve for a. And this now will go for any, sorry, I'm trying to catch my thoughts. Any function, okay? If you have 3 unknowns, the plan is always to sub in a coordinate. Why? Because if you sub in an x and a y, there's only one unknown left. Right, so let's say for argument's sake, I have the x value down, the y cut. So that's 0 and minus 8, okay? And I now want to solve for a. So now I need to make y negative 8, and I'm going to make x 0. Now, most of you put zeros in here, but watch this. If x is 0, then I just do this. And now I can see there's immediately minus 8, divide by the minus 8, and a is now going to be 1. All right, so if x is 0, it's gone. Okay, I know, thank you. It's a pleasure. All right, and now let me show you my huge brain. Minus 2 over 3 minus 12 over 3 is minus 14 over 3. Very good, me. Right, and there's negative 14 over 3. Right, and also get in the habit of doing this. How did I get this y cut? I made x 0, and it gave me negative 14 over 3. I find that when you actually re-look at what you've done here, you can understand the concept of where these coordinates are going. All right, x cut. Right, find me the x cut. The x cut usually takes a little bit more work because now you need to use inverse operations in order to solve for x. Right, now why do I like a hyperbola so much again? Is because I know that negative 14 over 3 has to be less than minus 4, and I can see that I'm already expecting a negative x value. So even if your math is a little bit wonky somewhere, you can definitely go fix it because you are anticipating certain solutions. Huh? All right, go. Solve for x. Okay. I've got 2 different answers coming in. Right, so inverse operations. Great. Trying to solve for x. Okay. I hate fractions. Well, I love fractions. You guys hate fractions. How do we get rid of fractions? Multiply by the denominator. So let's just take the extra step. I like to do it in one go, but again, there's mistakes. So you got 4x plus 12 equals negative 2. Right, we're going to minus the 12, gives you negative 14. Divide both sides by 4 and gives you negative 7 over 2. Right, and there you go, negative 7 over 2, which is less than minus 3, or p. And so now we know we've got our correct values. Math, easy. Just join the dots. Okay, moving on to the axes of symmetry now. Okay, right. Oh, before I move on, I want to show you something amazing. I know our versions of amazing are slightly different. Just bear with me. Oh, sorry, I've got a better way of erasing next time, promise. Okay, here we go. So if I've got now y equals all this business, we know that this plus 3 is always an additive inverse. Okay, remember, whenever we've got x, in fact, even in our quadratic over here, we know that x over there was going to be positive 4 and x is going to be negative 2. Why? Because we make y 0 and we have to back solve for x, and that's why you end up getting inverses. Why do you never get an inverse for y? Well, because y is the subject, the inverse operation has already happened. What do I mean by that? Watch this. First of all, watch this. Right, that was much better. Okay. What I'm going to do now is I'm going to do this. I'm going to add 4 and then say equals minus 2 over x plus 3. Okay. Why am I doing this? Because this minus 4 has actually come over from the y side. And I want to explain this to you nicely. You see my origin is at 0, 0. My new origin, give me the coordinates of my new origin. What's the coordinates of my new origin? What are those? What's that coordinate there of my new origin? You can see the origin has moved. Hey? That's what those asymptotes mean. It was the initial Cartesian plane that's moved. Right, good. It's going, the x1 is negative 3, right? We know that the x is negative 3, and we know that the y is negative 4. Sorry, don't get confused by that blue dot. The 7 over 2 is the x cut, okay? So now we know that that's the origin. Tell me, what would you have to do to the origin, that where it is now, to put it back. How would you put this origin back? What would you do to the x value? Oh, you'd have to add 3. Oh. And what would you have to do to the y value? Oh, you would add 4. And that's what these shifts actually mean. You are moving the origin. Amazing. I know. That's why, and that's what I'm saying, is that the reason it's misleading is because this -4 has already been taken over to the other side, and that's why you don't notice how these shifts actually work. Yeah, you can sleep better tonight. I know. Good. Okay. So now, what does this mean? It means that my axis of symmetry has moved as well. It's no longer passing through the origin. So now, this was the graph of y equals x. But what's the equation of a straight line? Y equals mx plus c. We know the gradient hasn't changed, so I'm just going to say, right, y equals x plus c. How many unknowns are in there? 3. Remember what I told you earlier? Keep that in mind. Right, so now what's this? Here's now the other axis of symmetry. That's also moved. Now, this one was the line y equals negative x, but there's obviously been a shift. So we go plus c. Also 3 unknowns. Right, let's start with the positive one for the time being. How do you solve an equation of a straight line? Well, you get the gradient, and then you sub in a coordinate, right? So now, here's my y equals x plus c. How many unknowns do I have? I've got 3. Do I have a coordinate that belongs to that axis of symmetry? I do. Where? My new origin. Haha. This -3 -4 is passing through because it's where the new origin is. Haha. So that's what I'm going to do. I'm going to make y -4. I'm going to make x -3 plus c. Add the 3, gives me -1. And now I know that the equation of that line is simply going to be y equals x minus 1. Haha. Same story up here. Right? Well, y is -4 when x is -3. Check that sign change over there, right? So that over there is going to be +3 minus the 3 from both sides, -7 now. So y will equal minus x minus 7. You can go and double check your x cuts. So this x cut over here was -1. Let me go and have a look. Aha, that seems pretty reasonable. This y cut down here is -7. Oh, that happened down there, pretty reasonable. And there you go. Right. Now, some people are putting in, there is a method. I don't know the method, but it's something like y equals x minus p or minus x minus p. I don't know. I just know how to get the equation of a straight line. Y equals mx plus c. I already know m. Sub in a coordinate, get the line, be finished. Okay. Anybody tell me how, last question, I'm going to give you guys a break. How will I find this point over here? Now, I don't think we'll be able to do the math for this particular equation because it might be a bit extra. How do I find this point over here? What is that point called? What do we call this point? Good. Good. Right. It's called, well, for some people, a POI, right? A point of intersection. Okay, a point of intersection. The reason your matric teachers probably don't use POI is because next year POI actually stands for point of inflection. Again, you got that to look forward to. But yes, it is a point of what do we say? Intersection. All right, it's a point of intersection. Right. And I see some very lovely answers coming through here. How do we find a point of intersection? You literally make the graphs equal. Why? Because they're equal there. So we're going to say -2 over x plus 3 minus 4 is equal to x minus 1. Mathy, it's going to become quadratic. Why is the answer going to become quadratic? What does it mean for a function, for an equation to all of a sudden become quadratic? What does it mean for something to become quadratic? How many solutions am I going to expect? Good. I'm going to expect 2 solutions. Why am I going to get 2 solutions? I'm trying to find that point of intersection. Why am I going to get 2? Yeah, that is why. But why am I going to get two solutions? That, yeah, again, that's fine. But look at the graph, guys. How many points of intersection are there? between that axis of symmetry and the, I put even the wrong graph in here. I was supposed to use the other one, wasn't I? Negative x minus 7. Nobody corrects me on that one. Remember, it's the negative graphs, okay? Well, how many times is that line passing through the hyperbola? Ah, there you go. It cuts it twice. Where? Over here, the one I'm looking for. And again, down here. And that's why you end up with two solutions. Which one am I going to choose? The one further left. Why? Because I want the one further left. So you're going to get two x solutions. You choose the one you want, and then you sub that back in to find the y value. Very nice. I'm amazing. You were great. Okay, let's take a 10-minute break, and I will see you back here at, let's do this. All right, your turn. On the same Cartesian plane. Right, go for it. And you'll see. Sketch both functions on the same Cartesian plane. What do you need for any function? X cuts, Y cuts, turning point. Go. Okay, let's have a look. So the first thing that I do, the second I see it's a quadratic, is that I'm going to factorize it. Now, you must also remember is that what are the rules of factorizing? First, look for a common, then either difference of squares or trinomials, then grouping and so forth, right? So the order you're taught factorizing is first find out the highest common factor, and then it's either dots or trinomials, okay? So same thing in this case, first take out the common factor of -2. And you can see now what the equation always is. Ax squared, a x1, x2, a x minus p squared. That a value is the same throughout, okay? So I take out the factor, and you can see now, okay, great. I have now a trinomial, which I can factorize. Again, if you're using your calculator, guys, that's more than okay to find these things. And then, right, now you can see I'm attempting to get into turning point format. Right, let's go the long way around for those of you who don't have those fancy calculators. Now, again, I can already do this because you see that's 4 and -2. So because I know that the one x cut is 4 and the other x cut is -2, I already know that the axis of symmetry is 1 because it's halfway between. All right, if you want to go extra, we know that p is equal to -b/2a. We're going to sub in the b value from the original equation, which is +4 over 2 times -2, and you can see there we get 1. And remember what I told you now, we sub in the p value, which is 1, right, f of p. And now after you sub in that 1, plus 16, then you end up with, who can tell me what is the answer? 18, I think. Yeah. Good. All right. So now how do I transfer these values back into the equation? I'll show you now if I can get my pen to operate. Oh, there we go. Okay. So what do we do? Well, I know now the formula is x minus whatever the p-value is. In this case, it's 1. And then whatever the q value is, in this case, it's positive 18. And now you have completed the square. All right, great. Right, so now how do I draw this parabola? Well, we're just going to draw the dots. And that's what I'm saying. Like, functions is great, especially when you're asked to draw them, because then I'm going to make it hard for you now, don't you worry. But anyway, let's go draw this graph now. All right, so what do we need for any function? X cuts, Y cuts, turning point. Great. Where's the Y cut? Oh, it's 16. Remember, this 16 over here is the constant. So I know that the Y cut is going to be 16. Great. My X cuts are at -2 and positive 4. And I've got a turning point at 1 and 18, which is somewhere up here. 1 and 18, called a maximum in this case, because it's the top of the graph. And we go, oh, please do this nicely, coming around and down again. Ouch. All right, great. No, okay, good. I'm glad you asked that question. Okay. Remember, guys, okay, so the question is, why did I just put in the 1? The formula, the general formula for the straight line, right, for the quadratic, is ax squared plus p plus q. Okay, this is now the formula. If, for argument's sake, the turning point was the other way around, so let's say that this was 2 now, and this was -4. Now you can see that this is going to be -1 and whatever the y value is. Now, if I sub into the formula, let's again just say a is, let's just go 2, whatever, it doesn't matter. Okay, then I'm going to go x minus. Right, what is the p-value? It's -1. And that's why it ends up becoming positive with a shift to the inverse side. Right, do never, ever, ever force signs in math. It's like if you were solving for a, for argument's sake, we know that a is going to be -2. You don't make the a 2. Once you've solved, it will present itself as a negative because it must be. Don't change signs in formulas, especially with the x values. Okay, does that answer your question? Okay, right, moving on. Great. Always additive inverse with x. Always. All right, now I just want to make my graph a little bit longer here so we can just see what's going on. Okay, so this goes on a little bit further. Why do I want to see that? Because now I can also see that I'm going to have 2 points of intersection. Okay, right, great. One over there and one over there. Great. Your turn. Right, so this is the question. Determine the coordinates for which f of x is equal to g of x. Right, determine the coordinates for which f of x will equal g of x. How do we do this? Right, we equate them. Why? Because it says make f of x equal g of x. Fantastic. So here we go. -2x squared plus 4x plus 16 will equal x minus 4. Right, go, mathy. Let's see your math. -8 plus 5. Yes, my maths, so good. All right, obviously I'm factorizing. You could have quite easily use your calculator if you've got that function on your calculator. And if you don't, get that calculator, okay? It's this fancy Casio. I don't know if you have it, you're welcome to type it in the chat column, but you literally go mode equation, you punch in the coefficients and it spits out everything. Yes, you're allowed that calculator. It's not magic. Look, I do prefer old school math, but I promise you, it'll save you at least, I would say, half an hour in an exam just by finding x cuts and turning points. All right. Now, the question was, determine the coordinates for which f of x equals g of x. What do I do now? So tell me, when x is 4, what's the y value? Good. Right, we already knew this, right? We saw them passing through the same x cuts, so we know that y is 0 over there. Right, Or, right, what do I need to do now? I'm going to make that negative 5 over 2. And what am I going to do with that negative 5 over 2? Sub it back in. Where? Into anyone. Right, why? Because I want the y value. Remember, g of x means y. So y is x, which in this case is negative 5 over 2, minus 4. You could have subbed into the quadratic if you wanted to, and that's going to be negative 13 over 2. Right. If you're wondering why my fractions are so amazing, I'll show you what I'm doing in my mind. I'm making that negative 5 over 2, so I'm making that negative 8 over 2, so it's negative 13 over 2. I'm just getting the same denominator and adding those things. Okay, somebody's, all right, why is y equal to 0? Well, let's have a look. Let's say I made x equal 4, so 4 minus 4 is 0, and again, Amara, we can see that they are passing through the point 4 and 0. All right, again, sub in and you can find out for yourself. But I didn't in that case because it was fairly obvious over there. Okay, good. Very nice. Okay, we're getting there. All right, I just want to put those coordinates on my drawing, and then I'm going to ask you another hard question. So that's going to be that x value there, right? Negative 5 over 2 and negative 13 over 2. Great. Okay. Now, all right, here comes your favorite question. Let me start easy with you. Hold on. You know which questions I'm going with that. For which values of x? Okay. Now, the first thing I want you to understand is what does it mean for which values of x? X on a number line is always where. Y on the number line is always the value. So if a question says for which values of x, they want to know where. For which values of x? No? And where is width of x? Right, well, right, let's start with a nice easy one. Well, all right, this is graph of f. Right. For which values of x will f of x be bigger than or equal to 0? Right. What does this mean? Right. F of x are the y values of the parabola. So it wants to know where are the y values of the parabola positive. Great. So let's go and have a look at where y values are positive. Okay. Well, if this is now the y-axis, then it stands to reason that these are all the positive y values. Great, right? So y is positive anywhere above the x-axis. Great. So I've found now where y is positive. Right? That's the positive y values. Now, where is the parabola having those positive values? Which x values give that parabola positive values? Very nice. I see some answers coming through. Good. Good. Right, we can see that the graph is going to be positive above the axis. Why? Because that's where the y values are positive. Okay, great. So I found where the y values are positive. Where are they positive? Oh, I see. Between negative 2 and 4. And those are the x values, eh? The x values are between negative 2 and 4. Including or excluding? Well, it says it can also be equal to 0. So great, I'm going to include the x cuts. And now you can see that x is between negative 2 and 4. That is where the graph is positive. Fantastic. All right, next one. So where then is g of x going to be less than 0, right? That just means negative. Where is g going to be negative? Where is the graph of g negative? Okay, that's one way of saying it. Good. All right, well, let's take a look. What does this mean now? It means now where are the y values of the straight line going to be negative? Okay, great. So it stands to reason then that the y values are all negative down here. Great. Where is the straight line negative? Oh, okay, great. The straight line is negative all the way. Now, how can I write this? Now, people who have got negative infinity, you are correct. I'm not going to slate you on that. But now, where is this graph negative? Oh, anywhere before minus 4. Oh, great. So then x must be less than 4. Anywhere less than 4, the graph is negative. Okay. Some people are putting infinity in, so saying from negative infinity up until 4. That's also acceptable, but what's the point in this? Right? Less than 4. That means all the way to negative infinity. Okay. If you find yourself putting infinity in your inequalities, it's totally unnecessary, because saying x is less than 4 is exactly the same thing. Okay. All right, here comes the tricky one. For which values of x will f of x be bigger than or equal to g of x? Okay. What is this now asking? Where is the parabola bigger than the straight line? Where is the parabola? What does it mean to be bigger? The y values must be bigger, huh? So in other words, what does that mean? It means the one graph must be above the other graph. Who must be above? The parabola. Great. So maybe you should start looking where they are equal. Then you know at least when they're equal. Then you can check when the other one is bigger. Very nice, Willem. Where? Yeah. Where is the parabola bigger than the straight line? Careful, Benati. Have a look. It keeps going, huh? So where's my pen? Oh, here we go. Right. So have a look here. There we go. Look here. This is the whole section. I can see now the parabola is above all the time up until there, right? And that's why points of intersection are sometimes called critical values, because I want to know whether they're equal and then bigger or lower. Ah, there you go. Well, negative 5 over 2. Okay? Right. So so now that we found the y values, you see that we found the height. Now, what are the x values that make that height true? Oh, okay. From negative 5 over 2, that's where they are equal, up until 4, when they're equal again. And x is between all those. And am I allowed to include it? Yes, because there's an inclusive sign in the question, and that's why I include it. So that's where the one graph is bigger than the other. Okay, good. Moving on a little bit. Right, here's another typical grade 11 question. I'm just going to be smarter here. There is a line. Let's call it PQ. Oh. PQ. Be nice to me. No, PQ is not being. There we go. Right, PQ is a vertical line, right? Which means it's straight distance. So I don't need distance formula or anything like it. Okay. Now, the amazing thing about this line PQ, let me just label it PQ. Right, it can move in between the function. Obviously, it'll get smaller and bigger as it goes, okay? Because PQ is now a distance between the functions where the parabola is bigger than the straight line. Great, so that's the parameters now. I want to know what is going to be the maximum distance of PQ, the maximum distance of PQ. Now, I want you to understand what this is going to look like if we were to graph the distances between the functions. So let's just start a little Cartesian plane over here. Right. If I start at this point here, negative 5 over 2, the distance between the functions is 0. So I'm going to put down a 0. Now, it's quite interesting. If I asked you, where's f of x equal to g of x? It would have been the same thing as doing this. Okay? You see, I've just done some basic algebra. What does this mean? Where is the distance between the functions 0? And when is the distance between functions 0? When they are equal. Hello. Okay, so that's a cool way of seeing it. So how do we get the distance between functions? We literally just minus them, the bigger one from the smaller one. And that's the strategy we're going to use just now. All right, well, let's just go back to what I was saying. So the distance between the graphs starts off over here as 0. Now look here. This starts to get bigger and bigger and bigger, right? And then it starts to dip off. In other words, it starts to get bigger and bigger and bigger, the distance between the graphs. It reaches a maximum distance, and then it starts to come back down again until the distance between them is 0 again at this point. And now you can see, okay, so the distance between graphs can actually be measured in quadratic formula. Why? Because you can see it goes a little bit bigger, hits a maximum turning point, and then shrinks down again. So how do you find the maximum distance of a function? You minus them and then find the turning point. Right, let's do this. Right, so now I want to know, find me the maximum value of Pn. So here we go. Pn will equal the parabola minus the straight line. Right, and let's do some nice mathy. So we're going to take the equation of the straight line, negative 2x squared plus 4x plus 16. Thank you. Right, minus bracket x minus 4. Right, this bracket is super important because, yes, it's going to change the sign of both of them inside there. Great. So that means negative 2x squared minus x plus 3x and then plus 20. All right, great. Okay, everybody happy with that? This Pn now, what does that mean? That represents the distance between the function. That Pn is a function of distance. Why is it quadratic? Well, as we said earlier, the distance is going bigger, at a maximum, and then smaller, so it makes it quadratic. Right. How do I make Pn now a maximum? Right, we need to get it in turning point format again. All right, and this is going to take a while without a calculator, but let's do it anyway. All right, so P will equal negative B over 2A gives me positive 3 over 4. I'm going to sub that 3 over 4 in now. So Pn will equal negative 2 brackets 3 over 4 squared plus 3 bracket, 3 over 4 plus 20. All right, I need that answer, please. My brain is not going to be that great. Right, and then in order to complete the square, I'm going to take out the negative 2. I'm going to have x minus, what's the p-value? Okay, it's 3 over 4. I just put the 3 over 4 in, close the bracket, and I doubt, is it really going to, oh, well, you can tell me what this value, I know it's going to be positive, obviously. What is this value down here? I'll just wait. Please don't make me use my huge brain. Come on, what is this? Somebody, thank you. 21,25 or 169 over 8. Great. 21,125. Great. Okay. Don't forget my square. Okay. Everybody happy now how to complete the square? Pretty simple. You just find the p-value, sub it in, and now you've completed the square. And you see the a value again, you just put it in front and just carry on the formula. Good. So now, who can tell me what is the maximum value of PQ? What is the maximum value of PQ? All right, I'll give you your options. Oh, la, la. If I swear out loud, it's just the lightning is coming in close. All right, where are we? Right, so there's your 3 over 4, and there's your 21,25. Okay, what does this mean, guys? What is the maximum value of Pn? Right, I'm going to put the coordinate over here because that's what that means. There's your 3 over 4 and your 21,125. 21,125. Yes, good, Benati. This is your answer over here, 21,125. Yes, good, Miriam. The reason being, guys, is because what is a turning point? It's your axis of symmetry and the biggest value that it can possibly be. That's why it's or the minimum, depending on the question. But now, what does this mean? It means that PQ at its maximum is going to be 21,25 units. Right, that's what that means. If I asked you, where is PQ a maximum? Who can tell me, where is PQ a maximum? Where is PQ a maximum? Yes, so what's the value? Yeah, remember, it's a single answer. If I said where, am I asking for an X value or a Y value? All right, if I said where, your answer is going to be positive 3 over 4. If I said, what is that maximum value? It's going to be 21,25. Remember, guys, X is always where. So what does this mean? Oh, well, there was my let's call this the axis of symmetry at 1. What does it mean? It means PQ is its maximum distance of 21,25 when x is 3/4. Right, and that's why we complete the square, to find the largest value of a square, if you really want to get into it over there. Okay, good. And this is probably one of the more difficult questions in grade 10, obviously for which values of x, and then to find a distance between functions. But again, guys, the recipe remains the same. If you want to find something called a maximum, you will ultimately end up with a quadratic. Why? A maximum or a minimum simply means find the turning point. Express it in turning point format and simply pick out the Q value if they're asking for the actual value. Good. Okay, let me trust you now to some work. Let me see. All right, let me just get out of here. Right. Dun, dun, dun. Benati, I don't, in matric, there is another method for finding that, and it's to use derivatives in calculus. But in grade 11, you minus the functions and you complete the square. Okay. Good. Here we go. We may as well. All right, here we go. Sketch the following on a separate set of axes, label all relevant points, intercepts, and asymptotes. Okay, we're not going to do that. Well, not at least not the first one. Tell me what function is A? What function is A? Good. It's a straight line. Why? I'm looking at x and I can see it's only to the power of 1. I know it's going to be linear. Fantastic. Right. What is B? Good. Exponential. Right. What is C? Great. And I'm going to throw in a third one. D. Y equals 2 over x. What is D? Hyperbola. Right. So that's how you know what function it is. If it's x to the 1, linear. To the power of x, exponential, x squared, quadratic, and divide by x anytime. In fact, here's another one. What is this? Y equals x plus 1 over x minus 3. Who can tell me what function is that? It's a hyperbola. Why? You're dividing by x. The second you divide by x, you have a hyperbola. I don't care what the numerator looks like. The second you divide by x, you've got yourself a hyperbola. Okie dokie dookies. Let's have a look at question C over here. I like these kinds of questions. The IB love these questions. All right. Y equals ax squared plus bx plus c. Right. A must be bigger than 0. What does that mean? It must be positive. Great. A is positive. What does that mean? Smiley face parabola. Parabola. Great. B must be negative, right? Less than 0. Which means, all right, now I'm going to use my huge brain here. If B is negative, there must be a horizontal shift. So because it's negative, it's going to be a positive shift, blah, 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 right? And then they're telling me that B squared minus 4AC, the discriminant, the discriminant, is less than 0. Okay. Tell me, guys, before we even get into these other things, remember what I asked you about this discriminant. What is the discriminant? It is distance, okay? If you understand it as distance, I promise you now it's going to make your life 100% easier. Because if I told you the distance was less than 0, what does that mean? If distance is less than 0, can you get negative distance? Oh, good. It's unreal, right? There's no such thing as negative distance. So now you have non-real solutions. What does it mean if your roots are non-real? What are roots? What are roots? What does this word roots mean? Good. The word roots literally means x-cuts. They're solutions, eh? So if roots are non-real, it means that there are no x-cuts. Great. Okay, fantastic. So there are no x-cuts. Right. Now, what do we know? The graph then, if it's happy without x-cuts, is either going to look something like this, you need to see a shift, or it's going to look something like this. Great, with the turning point on the other side. How do we know? Well, I'm going to do this. y equals positive x squared, right? B must be negative, minus 2x. And then I'm just going to put here minus 8. It doesn't really matter because I know there's no y cuts. All right, and then I'm going to factorize this with a negative b value. So it's going to be minus 4 and then x plus 2. And now I can see the x cuts are going to be at 4 and 2, shifting the graph to the right. And now I know I'm going to use this one. Right. So guys, if they tell you that A must be positive or negative, make A positive or negative and things like that. And you can see exactly what the graph means. Don't be intimidated by variables. Make your own numbers. Okay. Good. All right, where are we? 5.2, DBE. Here we go. Okay. The point A354 lies on this fancy graph over here. Determine the value of P, determine the range of F, and then find this business over here. Right, 7-mark question. I'm going to give you 7 minutes. No, I'm going to give you 4 minutes. Go for it. Sub and solve, huh? Sub and solve. Gotcha is, thank you. Right, so we've got f of x equals blah, blah, blah. Right, the first thing I like to do is write it as y. The reason I like to do that is because I don't know why, but f of x doesn't just look like y. So then there's my y, there's my x, and there's my p. And again, guys, how many unknowns are there? 3 unknowns. What is always the plan when you've got 3 unknowns? Sub. Why? You don't have the skills to solve with 3 unknowns, maybe 2 using simultaneous equations, but not 3. All right, so now what do? We sub in a coordinate. So y is 54 when x is 3, coordinate pair. Add the 27, prime factorize, and solve for p equaling 1. Fantastic. Great. Now I put everything back in my formula, and I've got y equals 3 to the x plus 1 minus 27. All right. Determine the range of f. Well, let's have a look at what this graph looks like. We've got this minus 27 that we know is a asymptote, y equals negative 27. I know it's a positive function. Remember that trick I showed you earlier? I know it's increasing because that's positive, and so is the x value. So I know it's an increasing function. So it must miss the asymptote and be an increasing function. Great. So who can tell me what is the range? First of all, who is range, x or y? Y, okay, the range, the game ranger, he's looking like this up and down, okay? The domain is width, like symbol, the domain from the east to the west, whatever. All right, the domain. Anyway, moving on. So what is the range in this case? Where are all the y values? Where are all the y values for this line? Where are all my y values? Anybody? Right, there's my asymptote. And my y values are over here. There we go. Y is bigger than minus 27. Do I have to say up until infinity? No. Y is bigger than negative 27. That's going all the way to infinity. All right. Am I putting a bottom lip on my crocodile? No. Why not? Because the asymptote was there. Good. Right. So y is simply bigger than minus 27. Great. All right. Next one. So I have done this with you earlier, if you remember. The graph of G is obtained by reflecting the graph of F about the x-axis. Okay, there's the x. Aha. Oh, so what's happening? If I do this, I'm changing height. Great. The graph of G, great, that's some imaginary graph, is obtained by reflecting F, my original graph, about the x-axis. Great, so I'm going to fold it like this. Find the coordinates of the x-intercept of G. Give me 2 ways of doing this. How am I going to find the new y-intercept? How am I going to do this? Okay. Yeah, okay, fine. So there's a couple of answers coming through here. All right. So the one suggestion is, right, if we're flipping it down, we're going to make y negative. Great. So I'm going to go negative y equals 3 to the x plus 1 minus 27. Redivide by the negative. So y will now equal negative 3 to the x plus 1. Remember, this negative is actually an a value. Plus 27. We're changing the sides. Right. And now what are we going to do? So there's the function of g now. What do I want? There we go. I'm going to make x 0 because I'm looking for the y cut. So y will equal negative 3, put in a 0 plus 1. Remember, we're making x disappear. Plus 27. And negative 3 plus 27 is now going to equal 24. Great. What was the other way of doing it? And don't forget to change all the signs when you divide by negative. What's the other way of doing it? All right, well, let's have a look here. If the reflected y cut is 0 and 24, who can tell me what was the original y cut? What's the coordinate of this original y cut? What's the coordinate of the original y cut? 0 and what? Come, be a genius. Yay, negative 24. Because what happened when we flipped it up? The y values changed. So you could have just found the original y cut and then flip it up, which I think would have been slightly easier, but it really makes no difference. Reflect the function, find the y cut. What difference does it make? Okay. Now you'll see this is only worth 2 marks, and you'll see this is a DBE paper. And the interesting thing about a DBE versus a IB paper is I feel like the IB, you get the marks for what you deserve, right? So if there's 3 steps, there's 3 marks. Whereas with the government papers, these difficult questions at the bottom, I find tend to be worth less marks than they should be. And I think it's just because not everybody fails the difficult questions all the time. So just keep in mind that as we go throughout government papers, just have a look that your questions are increasing in difficulty every time. The IB set their papers up slightly differently. Okay. Okie dokie dookies. And sorry guys, did you hear James earlier? We delayed a little bit because of the load shedding schedule and switching over. So we're probably going to end it probably about half an hour later than you expected. I do apologize because that means I'm also half an hour later than expected. But anyway, we're going to have lots of fun. So just stay on there. Okay, moving on. R, negative 1 and 9. Great. Is the turning point of the graph, blah, 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 right, in standard form. Doesn't really help us. We hardly ever, in fact, if never, sub into the standard form formula for the simple reason is that there's too many unknowns. There's A, B, and C, not to mention the Y and X as well. So that's why we either choose the X-cut format or the turning point format, depending on what information has been given. In this case, I can already see that's minus 1 and 9. So I'm already deciding to sub into the turning point format. Right, P and Q are the intercepts. Great. TV is a straight line. Ooh, guess we're going to be asked to find the maximum length of that line just now. It's parallel to the y-axis, it's straight. The graph of y equals x plus 4. Okay, great. Has an x-intercept at P. Great, so I already know now. And have a look here. If this is 4 and the gradient is 1, remember, what is the gradient? The gradient is the change in y over the change in x. Which means if the gradient is 1, there's a 1-to-1 relationship between height and width, which means if this height is 4, I immediately know that this number is technically also 4 because 4 divided by 4 is 1, and the gradient was 1. But because it's on the left-hand side of the axis, I can just make that minus 4. Okay? Now, here's another clever thing, and I hate to ruin this whole question for you, but watch this. Here's now the axis of symmetry. Let me just fix it nicely. Right, there's my axis of symmetry. Which means this over here is minus 1. Which genius can now tell me the value of Q? No geniuses? Here's your axis of symmetry. How many jumps from minus 4 to minus 1? If that's axis of symmetry, you need to do the same amount of jumps. Careful now. There you go, 2. You're going from negative to positive, so careful, guys. Oof, ouch. Yes, guys, integers. From -4 to -1 is +3. So from -1, add another 3. First, get out of the negatives. So -1 plus 1 is 0. You got 2 left to add. Ouch. 2. That's the middle. Okay. All right. All right. And now, I mean, I haven't even read the questions yet, and I've got half this info already. Okay. I mean, I'm winning here. Okay, good. Blah, 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 blah. All right, here we go. Right, your turn. All right, so unfortunately, it's not on the same page. Let me see if I can be clever here. Oh, look at this. I wonder if this is going to work. So I'm trying to bring it to the front. I'll tell you what, I'll just do this. All right, here we go, guys. Oh, now we raised half. My writing didn't go with. That's great. Okay, well, anyway, it doesn't really matter. You can do it anyway. All right, your question from the beginning. Then I don't need to worry about whether I've given away too much information. Right, there's your questions. There's your program. There's your problem. Let's go. Oh. Sorry, guys. Let me just fix this. It's ugly. I know. Let me click on you. Oh, that's fine. Monique, just pause for a second. Let me just resize this thing, please. Sorry, guys. I don't got it. No, I don't got it. This is embarrassing. I can't even get this thing out of the way. All right. Anyway, guys, you have the questions in front of you, don't you? While you just laugh at me from your comfort of your own home. All right, go. All right, thanks, Monique. We're just going to have to deal with this. I can't get these questions in the right place. All right, guys, while I'm fixing this, you can start the questions. Stop laughing. All right, go. Thanks, Rotendo. That was painful. I can only imagine how you guys were like, yes, this old guy just trying to figure out how to move stuff. Oh, look at this now. Hey, don't laugh at yourself. All right, there we go. Okay, I'm just gonna leave that there. All right, is for no, I didn't say the gradient was 4. No. I said the gradient is 1. Y equals 1x plus 4, which means the ratio of x of the change in y to the change in x is 1, right? This is a 1-to-1 ratio. In other words, if the y cut is 4, which is up here, then immediately this must also be 4. Okay, now why? Because height over width must be 1, right? That's what the gradient means. But it's a -4, obviously, because it's on the left-hand side. Okay, I wouldn't. So basically, what is this question actually asking you to do? Find the x cut of the straight line. You don't have to be a hero, but I mean, that's what it is, isn't it? I just want to add on to that. Watch this. Who's this? If I had y equals, say, 2x plus 8, okay? Now, what do I know? I know that the grade, the y cut is 8. I know it's a positive line because the gradient is positive. So I know it's doing this, and I know it's steep. Now, if the ratio is 2, right? So the change in y over the change in x, the ratio is 2. So if this is 8, then this must be 4, because height to width must be a ratio of 1 to 2. But it's -4 because it's on the left-hand side. And you can use these ratios all the time. I mean, that's what a gradient is. It's a ratio of height to width. Right, and also, guys, remember it says write down the coordinates of P. So it's -4 and 0, right? If you don't write it as a coordinate, you will not get the mark. I know, it's extra, I know. All right, and again, we know this is -1. So now we know that this is +2 and 0. Okay, so Q is 2 and 2. Great. Calculate the average gradient. All right, between P and R. Tell me, guys, what does it mean to calculate the average gradient? What is an average gradient? And why have they used the word average gradient? That's the other question. Right, so there's the line. What is the formula, guys, for an average gradient? Anybody? Where have you heard the word gradient before? What's the formula for a gradient? Y equals, y equals, good start, Stevens. Yeah, it's the normal formula, right? So M is the change in Y over the change in X, okay? Now, this just came to me. I don't really use the full formula. You know what the formula is. It's Y2 minus Y1 over X2 minus X1, right? That's why it's an average, because you're basically getting an average. But, all right, this is the formula I like to use. I just go with the change in Y over the change in X. So if this coordinate at P is -4 and 0, what is the change in the Y value from 0 to 9? That's 9 units. So the change in Y is 9 units up. From -4 to -1 is 3 units. And that is the change in the Y and the change in the X, which means now your average gradient is going to equal 3. Okay. Why are they calling it the average gradient? Why are they not just saying find the gradient or PR? Why are they putting in that average gradient for business? Can you work out the gradients of a parabola? Yeah, good. It's not constant. All right. And that's what grade 12 calculus is going to do, where you can work out the actual gradient at a specific point. Now in grade 9, 10, 11, you just have a linear average gradient. Exactly. It's exactly. Good. Right. Show that for F, A is -1, B is -2, and C is 8. Show all your working for 6 marks. Am I allowed to sub in -1, sub in -2, sub in 8, and therefore prove that this is the graph? Am I allowed to do that? I sub in the values they give me, and then I say, therefore, because they work, it must be true. Can I do that? Definitely not, eh? Definitely not. If a question ever says show that, the reason they're saying show that is because you need these values to actually go on with the rest of the questions. And if you stuff this question up, then the rest of your paper is now done for. All right, so that's why they say show that. So at least if you weren't able to get those 6 marks, you can still carry on with the formula. Okay, right. Now we can see A was going to be negative anyway because it's an upside down parabola. Okay, good. Let's go back to this thing now. Okay, here we go. So here are my options for my parabola. Y equals ax squared plus bx plus c. And y equals ax minus x1, x minus x2. Sorry about that. And y finally is ax minus p squared plus q. Which formula are we going to sub into? Okay. Right. I don't care which one you sub into as long as it's not the first one. Right. There's too many unknowns over there. So it's definitely not going to be the first one. Can I use number 2? Can I use this one over here? Yeah, I can. Why? Because I've got both the x cups. Haha. Can I use this one over here? Yes. Why? Because they gave me the turning point. Okay. I'm going to use the turning point format. The reason being is because I was the one who came up with P's and Q's values. And if I made a mistake with P and Q and I carry on with that mistake, then there's going to be a bit of a disaster if I use the X-cut formula. It's not going to make any difference, but let's just have a look anyway. All right. The biggest problem that I find with even grade 12s as well is forgetting that A has a value, okay? A is part of the formula. Don't be a hero and forget it out. Do not make it negative. The math is going to work itself out. Watch this. Okay, here we go. So we're going to say y equals A. X minus. Great. What's the p-value? -1. So x minus -1 now becomes +1, like I told you earlier. right? And then plus 9, right? There's your maximum. Great. How many unknowns? 3. Ha! What do we do when there's 3 unknowns? Sub in a coordinate. Which coordinate do I have? Well, at least I've got P over here, which was my x cut from the straight line. So there's no ways I could have messed that up. So that means the y value is 0 when the x value is -4. Okay. And now you can see once you've subbed in a coordinate, there's only one unknown left. So I minus the 9. Right. -4 plus 1 is -3. Oh, let's just do this. -3 squared is now positive 9. Let's just carry on with this. Positive 9a. Divide by 9, and you can see, yay, a is -1. It was supposed to be -1 because we've got an upside down parabola. All right, do not force the negatives in formulas ever. The math is going to work itself out. All right, now I still haven't proven the b and the c values. What do I do now? Well, I have one less unknown. Let's put it back in the formula. So y equals negative x plus 1 squared plus 9. Haha. Now I'm going to jumpy everything. Right, if you want to square binomials quickly, square the first, double the product, square the last. Distribute that negative in there. Negative x squared minus 2x minus 1 plus 9 is positive 8. And there you go. And now let's go and have a look. Right. Show that a is -1, b is -2, and c is 8. And that's what I'm going to do over here. Aha, there you go. Therefore, a equals -1, b equals -2, c equals 8. Okay. Right. Let's say we had subbed into the x-cut format. So again, a is unknown. And we're going to say x plus 4 and x minus 2. Remember, it's additive inverse. Again, right now, I need another coordinate. So because you can see you've got 3 unknowns. Which coordinate haven't I used? If I use the x-cut format, I haven't used the turning point. So y is 9 when x is -1. Mathy, -1 equals a. Same story. Y will now equal -1. Distribute the brackets, x squared plus 2x minus 8. Jumpy, the negative back in, and there you go. All right, so whether you had used x-cuts or the turning point, same. All right, next one. Calculate the coordinates of S, the points of intersection of F and G. All right, good. How are you going to do this? We're not going to do it. We're going to equate the functions, mathy, solve for x. Great. Remember, it also says find the coordinates. So you're going to have to sub back in order to get the correct placement, because we know that it's equal at P and at S. So you're obviously going to get 2 solutions. It's going to be quadratic and so forth. All right, good. This is the one I do want you to do. Determine the maximum length of TV. Right, determine the maximum length of TV. Right. How are we going to find the maximum length of TV? Well, we are going to minus the equations, obviously. We've been through this. Right, so TV will equal what minus what? Which one minus which one? Good, right? The parabola minus the straight line, because the parabola is obviously above. Great. So we know that the parabola is negative x squared minus 2x plus 8. And we are going to minus bracket the x plus 4. All right, Mathy, let me see your final answer. Go. Right, you can pause, Monique. I'm going to give them 3 minutes. Okie dokies. Let's have a look. All right, so as we've discussed, how do you get a distance between things? You minus them. Great. Why are they asking for a maximum? Because I can see that it's a negative parabola. If they'd ask for a minimum, that can also happen, but you'll see the same concept applies. All right. Once they ask for a maximum, what do we need to do? We need to complete the square. And that's what I'm busy doing on the side over here. I'm using that negative b over 2a. I sub it into the whole formula. Okay. I sub it all in. And I'm hoping this answer is correct. Somebody said it's 8. What does that mean? If I sub now -3 over 2, every time for x. In fact, that doesn't sound like it's going to be that nice. Is it really going to be 8? What happens when you sub in negative 3 over 2? That sounds too nice. So I take negative, and then I'm going to say x minus 3 over 2 becomes a plus 3 over 2 squared. Right, that means you must sub now negative 3 over 2 into the full equation every time you see an x. So you're going to go, right, the q value will equal negative x squared minus 2x and plus, sorry, wrong formula now. Negative x squared minus 3x plus 4. Minus 3x plus 4 gives you 6.25 or 25 over 4, right? That sounds a little bit more reasonable. Plus either 25 over 4 or 6.25. I sometimes like to see fractions as numbers so I know how far up or down they are. Just like 25 over 4, you're like, okay, all right. So there you go. Right, so again, what's the question then? Determine the maximum length of TV between the points P and S. Right, therefore, what is the maximum length? Therefore, TV max is what? Yeah. Ooh. All right. Right. Where is the maximum? Where is the maximum? Where? If I asked you where is TV the max? Where is TV the max? Good, when x is negative 3 over 2. Guys, it is a coordinate pair. The where and how much. The where and the how much. Also, why can negative 3 over 2 not be the how much? Remember, this answer here will always be positive. Why will this answer always be positive in these kinds of questions? What are we working out? Fine, I should say units, you are right. It's length. That's why this answer here will always be positive if you are working, if you do it correctly. Okay. Okay. Right. Guys, let's take one short break. Well, 10 minutes. 19 marks. Thanks, Monique. All right, 19 marks. Big question. Here we go. Are you ready? All right, here we go. Okay, so f of x equals 1 over x minus 3 minus all that stuff over there. What function is this? Hyperbola. Great. Why? We're dividing by x. Great. Show that for only 2 marks. I know this question looks slightly intimidating, but you can see the first one over here for 2 marks. Show that f of x can be written like that. Okay, great. What's the plan? How are we going to do this? How are we for 2 marks? What's the plan? I think that could work. So the one suggestion is to actually find an LCD and keep going. That can work. But if we look now at this second term, we have a common factor, very nice, Humaria, of 2, leaving us with x plus 3 over x plus 3. Haha, cancel, and there's your minus 2 over there. Okay, so a mark for factorizing and for canceling will be due. Don't be intimidated. Okay, great. So now that is the function we're going to work with. Okay, that's now our function. Great. Fantastic. Next one. Write down the equations of the asymptotes. The equations. All right. Tell me the equations of the asymptotes using this function. Anybody? Equations of the asymptote. Oh, very good. All right. X equals 3 because that wouldn't work, and y equals minus 2. Very nice. Okay, right. There's your asymptotes right there. So your restriction is on the x value and on the asymptotes, right? The q value. Good. For 3 marks, find the x-intercept of f. Great. How do we find an x-cut? Well, we make y 0 because what do we know about an x-cut? There's no height. So here we go. 0. equals 1 over x minus 3 minus 2. We add the 2 and mathy this thing out. All right, go. Right, 0 equals 1 over x minus 3 minus 2. Add the 2. Right, now watch my clever math here. I'm going to multiply by the denominator. So it's 2x minus 6 equals 1. Save myself a little bit of time. 2x equals 7. So x now will equal 7 over 2. Great. And again, I'm just going to write it like this. 7 over 2 and 0. Right, I made y 0. And the x value that got spat out was 7 over 2. Great. Right, determine the y-intercept. For only 2 marks, the y-cut's always the easy one. So y will equal 1 over minus 3 minus 2. X is no longer there. And 1 over 3 minus 6 over 3 is negative 5 over 3. Over 3. Okay. All right, and again, what did we do here? I made x 0. And it spat out negative 5 over 3. Everybody happy with my 5 over 3? Okay, good. Sketch the graph of f, blah, blah, blah. Right, how do you sketch any function? Well, what do we need? X cuts, y cuts, asymptotes. So here we go. And again, why do I like the hyperbola so much? Lots and lots of restrictions. Right, what were those initial restrictions? Minus 2 for the y value. So there we go. Right, there we go. Y is minus 2. X was negative 3. X equals negative 3. Great. Which quadrants was this in? Well, it's a positive value, so I know it's going to be in quadrant 1 and 3. So there we go. Over there and over there. Now, I know some of your teachers, they're like, and put in one other point. For what? I know exactly where it's going. The reason they do that is so that you don't mess up where it's supposed to be. But remember, it's symmetrical. You're not going to get marks for plotting another point. Yeah, thank you. All right, good. So now, again, I need my x and my y cut. So let's go and have a look. Ooh, what's happened over here? Oh, my drawing is obviously, my drawing is terrible. Oh, why is my drawing terrible? Let's go and have a look. Why am I drawing so bad? All right, so what's my my y cut is negative 5 over 3. That's over there. There's your negative 5 over 3. Oh, my x cut. Is my x cut okay? Minus 6, positive 7, 7 over 2. Oh, yes, okay. Well, my y cut's wrong. Oh, good. What's my y cut supposed to be? Sorry, my negative 7 over 3. Oh, sorry. Oof, that fraction is negative. Oh, you see now, the brain has failed. Ouch. All right, so, ouch. All right, so negative 7 over 3. Sorry about that. Up. All right, and then your positive 7 over 2. And then all we're going to do is then sketch our function. Sorry, x is supposed to be positive 3. Sis, guys. That's all wrong. Sis. Because the asymptote's in the wrong place. Yuck. Right, let's try this again. Right, minus 2. At least we found it. Huh? Y equals minus 2. X equals positive 3. I was wondering why my cuts weren't working out properly. X is positive 3. Right, X may not be 3, obviously. All right, and then there we go. Now I can see where my cuts are coming from. Right, there's my X cut now as 7 over 2. And here's now my Y cut. There you go. Of negative 7 over 3. Whew. All right, just get the asymptotes in the right place, and then there you go. All right, anyway, I'm glad that happened, so you can actually see that if you make a mistake, you can actually go and figure this thing out. All right, great. This next one, right? Determine the axis of symmetry of F having a positive gradient. Okay, great. So again, guys, we've done this before. Here now, my new origin with my axis of symmetry passing through, and that's one of the positive gradients. And again, we know that the gradient doesn't change. All that's happened is that there's been a shift. How do you find the equation? You need the gradient and a coordinate. What coordinate are we going to use? Well, we can see it's passing through the point 3 and minus 2, so that's what I'm going to do. Y is minus 2 when x is 3, minus the 3, negative 5. So your final answer is y equals x minus 5, and you can see there's your y cut of minus 5. Okay. Good. Next one. And that's a 3-mark question for subbing into a coordinate. Okay, don't be a hero. Right, the graph of f is transformed to obtain the graph of 1 over x. Great. Describe the transformation from f to h. Great. So somehow now, let's go and have a look what's happening. This graph must transform to simply be 1 over x. Who can tell me what's happening? How did this happen? Yes. How did this happen? Anybody? Yeah, good. All right. So how, Benati? So you're not going to get any marks for that. I mean, I love your message. Shifted left or shifted right? What's going on here? Basically, guys, look here. All the shifts have gone, right? And I showed you this earlier. The new origin is there, and you need it back there. How is that going to happen? How are you going to move the origin back? Now, remember, how do we move things in a Cartesian plane? You can't move them directly at angles. You have to move them left, right, up and down, and those kinds of things. Right? So how are we going to get the origin back? Good. Careful. Definitely 2 up. Right? Definitely 2 up. And 3 which way? Get it back to the origin. Hello. There you go, Wyatt. Good. Good. And let's go and have a look. What do we need to do to get rid of this horizontal shift? Now, remember, it's always an additive inverse. So we know it's been moved 3 to the right. So in other words, how is the shift taking place? We definitely need to shift 3 units to the left, shift 3 units left. And what happened to this -2? Well, it's gone. So it's also gone 2 units up. Right. And that's exactly good. What happened from my, and that's what I said to you guys. What are these PQ things? It's the new origin, and you need to undo it to get it back to the origin. Okay. Right. And there were 2 marks. Write down the domain of H. Okay. So now we know we've just got this normal function that's everything's back over here. Right. Sorry, it's 3 is left. Sorry. So, yeah, left. Definitely to the left. Guys, understand this, please look here. Here is the current origin, the 3 and the -2. You definitely need to move it 3 to the left and then 2 up. That's definitely the shift. 3 left, 2 up. Okay? Always the additive inverse. All right. Let's go and have a look. Right, the domain. Let's just have a look at, and this will work. Okay, good. Right, here's now the new graph. The new graph, Relebogile, you were correct with the old function, but they now want the range of H. Write down the domain of H, not of F. What's the domain here? What is domain? Domain's X values. Tell me about the X values. All right? How far left are they going? And how far right are they going? Infinite, right? So in other words, X can be all the numbers. Is that true? X is all of the numbers. Is that true? Can it be all of them? Why is it bending like that? Remember why it's bending? Ah, very nice, Mamelo. So X can be all of them except 0. Right. It can be, because look, here's your asymptote now here. Right. So it can be all the X values except for 0. All right. While we are here, tell me about the range. What's the range of this function? So how far down is it going? And how far up is it going? Good. Y is now all of them, except in this case, not 0. All right. Same. Good. All right. One last thing, and then I'm literally closing functions with this. Let's just have a look. I just want you to see something. It's not that important, but I just want you to know it anyway. If, for argument's sake, this is the graph of y equals 1 over x. if I were to draw the graph of, for argument's sake, y equals 6 over x. Now, you're never going to be asked this, but I just want you to, so when you see a question, you can actually almost interpret this, what the size of the a value is going to be. So what this a value does is it literally just stretches that point a little bit further away from the origin. So if it's 1, it's very close to the origin. But now if it's 6, obviously it's still got the same asymptotes, but it's just going to bend further from the origin. So you can actually just see that if that number is really big, all that it does is it just stretches it further from the origin. Okay. Good. All right. Moving on to finance. Yay. All right, Monique, just pause. Let me just switch over to my staff. Pause the video. Pause. Okay, finance. Let's start with something really small. Let's say I buy a Coke for 10 Rand. And I want to mark up by 50%. So we're having like a grade 11 dance or something. I buy Cokes for 10 Rand. I want to mark them up by 50%. What am I going to sell it for? If I mark up with 50%, what am I selling the Coke for? Okay. Great. 15 Rand. Okay. Where did that 15 Rand come from? I'm glad you asked. Well, let's see. The amount we're going to sell it for. Well, it's going to be 10 Rand plus, right? What is that 10 Rand? That's my money, because I want to make it back, obviously, plus 50% of that 10 Rand. Great. 50% of 10 Rand is 5 Rand, and therefore it's going to equal to 15 Rand. Fantastic. Now, what's this? I'm going to take out a common factor of 10, and then I'm going to be left with 1 plus 50%. Right. I'm going to change this now into variables. What was this 10 Rand? Well, that's my money, my present value. That's what I have now. Then it's 1 plus, and then the interest. Haha. Ah, math. Now, what I want you to understand by this formula is what is actually happening. What is P times 1? That's P. That's my money. Plus the interest on my money. And that's why it works out like this. Now, what function is this? Who can tell me? If I were to graph this, what would it look like? P plus PI. Well, I suppose it would be a bit difficult to graph because it only happens once. But it would be linear. Good. It's a straight line, okay? Because it's simple interest. It's just going to be linear. Okay. Why am I saying it's only 1 point? Tell me, what are we doing here? What is this? Right, this is called markup. How many times does markup happen? Well, it only happens once. Why? Because I bought the Coke once, I'm going to sell it once. You're not going to mark up. But let's say, for example, you are now investing something continuously. Now what happens? Well, now you would be investing it a number of times. And that's why, again, it's your money, P times 1, my money. Well, that's actually 100%. Right? That 1 is 100%. Your money plus the interest on your money. So let's distribute in here, P plus PIN. So what does this mean? Your money plus the recurring interest on your money over time. Okay. And now we have the simple interest formula. Great. Math. Fantastic. Right, and you can actually derive all these formulas by factorizing, but anyway. All right, what happens now if I start compounding the interest? Now we know this, so we're going to have A equals P1 plus I to the power of N. All right, what is the difference? What graph is this? Tell me about, if you were to graph the difference between, right, we already know that simple interest is linear. What function is compound interest? Good, it's exponential, right? And that's why, and so now most of scenarios in math always require compound interest, inflation and those kinds of things, appreciation. Why? It has to do with the value of money. Remember, money is becoming worth less due to inflation. And that's why we always use compound interest, because let's say I borrow 100 Rand from you today, and 5 years later, I give you 100 Rand back. That 100 Rand is going to be worth less in 5 years' time. And that's why we compound interest, to make sure that it's going to meet inflation. Okay, good. So what is this now? If I were to just say minus I without the N, what am I doing now? Now let's have a look here. What do you think this formula is for without the N? What would happen if I took away interest once? Only once? Right, let's have a look. Let's say there's a sale. There's a 300 Rand pair of socks, probably. All right, with 25% off. What are you going to pay? Right? 25% off. What are you going to end up paying? Okay, good. Hey, Jose, how's it, bro? Yeah, 225. Why? Because what's 25% of 300? Well, that's a quarter. So a quarter of 300 Rand is 75 Rand. So that means I must take it off, and then you're going to be paying 225 Rand. But now watch this. Let's say I go like this. A equals, right, I'm going to take the 300 Rand, and I'm going to say 1 minus the 25%. Okay? Now again, let's analyze this. This is 300 Rand minus a quarter of it. Fantastic. Now remember earlier I told you that this one is actually 100%. So in other words, this is the same thing as saying 300 with 100% minus 25%, which is now going to be 300. I know this is a long way around, times 75%. Why? And that's going to equal 225. Why? Because, guys, if you get 25% discount, what percentage of 100 were you going to pay? Remember, you're supposed to pay 100%. But now you've got a 25% discount. So now I'm only going to pay 75%. Haha. And now what happens, and that's where your simple interest comes from. Yeah, exactly. Good. Right. So now what happens is we can see we're discounting. Now, if you earlier we were marking up. If you mark up numerous times, you're going to end up with simple interest. If you discount now numerous times, you are going to end up with depreciation. Right, now, before we get on to this depreciation, do we also get this kind of depreciation? Right, this is also depreciation. How do I know in the question which one they're asking for? Which one is which? What kind? Let's work with this one on the side here. What kind of depreciation is this one? This one. Right, this one is called linear or straight line, right? It's called straight line depreciation, right? Why? Because it's linear, right? This is called straight line depreciation. Straight line depreciation, okay? Now, this one over here is not called compound depreciation, even though that is what it actually is. Anybody know what, so remember, interest is plus, depreciation is minus. What do we call this kind of depreciation? This one on the side. Yeah, good. Reducing balance method. All right, the reducing balance method. I don't know why that's so extra. Reducing balance method. Okay. What is interesting about depreciation? Obviously, let's have a look at the two formula. Let's first start with positive interest. All right. If I were to graph, for example, this compound one first, okay? Let's say we start with $100 and we start to invest it at 10% or whatever the case is, right? Eventually, it's going to start exponentially increasing. And this is also why in a retirement annuity, you only take your money out at the end, because that's where the most growth is going to happen. That's so the longer you can wait for an investment, it's making its comeback at the end. Right. If we were to take a linear investment of 100 Rand, you'll probably find that it follows the curve for a little while. And then unfortunately, linear investment is just never, ever, ever going to catch up with compound. The irony here, though, is that if we have straight line depreciation, so let's say, for example, you buy a truck or something, right, for $1 million. Now, if it depreciates at a linear interest, it's just going to go down like this until it's actually worth less than nothing, okay? Boom, boom, boom. And then, look, obviously, it can't be worth less than nothing, otherwise you'd have to pay somebody to take it. But there we go, right? That would be straight line depreciation. Now, if you were to graph compound depreciation, what happens now, it actually depreciates a lot slower than what you would expect. So I'm just trying to think of what this graph is going to look like now. We're going to take our function and, oh, yes, it's going to, what is it going to do? Who is telling me, what is this going to do? If A equals P, 1 minus I to the N. What is this graph going to look like? Yeah, all right. So the reason I'm pausing over here is because it's either going to decrease like that, or it's going to decrease like that. I assume it's coming down like the other way. Right, so in other words, I think that it's going to come down like this towards the asymptote. Okay, and again, it is going to peak off because it can't be worth less than nothing because it's exponential. Okay, yeah, good. Okay, good. So that's your basic formula now that you're going to sub into in grade 11, okay, and also from grade 10. How does this now differ in grade 11? I'm glad you asked. I'll leave that up there for later. Okay, right, moving on. Well, there we go. If I've got A equals P, 1 plus I to the N, okay? That's your normal grade 10 formula. Now, some clever clogs comes along and goes 1 plus I over M to the power of Mn. What is the difference now between these two formula? Oh, well, and if you give me the nice name, what's the difference between these formulas? Yeah, okay, so fine. This one on the left is known as effective interest. What's the one on the right known as? Good, nominal, okay? Right. What is the difference between effective and nominal interest? Well, the word nominal literally means a number of times. So now we can see that the interest rate is being numerously compounded versus just effectively, which is over 1 year. That's why you divide by 1 year for 1 year, and that's why that's just over there, okay? That's why you don't see it over there. So effective interest is effectively the interest you would gain over 1 year, whereas nominally, you could do it numerous times in a year. The thing is, let's say my bank manager phones me, you're right, and says, oh, I've got a lovely offer for you. We're offering you 12% compounded monthly. And I go, okay, great, 12% compounded monthly. Effectively, what is that per year? Because 12% per month is not going to be the same as 12% per year. And I actually want to know how much I'm earning per year, not per month. So then the bank works it out and they say, oh, well, it's 11.84. Okay, so now I know, okay, cool. So it's not actually, it's 12% per month, but it's only 11.84 per year, whatever the case is. But if I sub in to the effective formula or the nominal formula, the A values must be the same. And that's why I can ask my bank manager to switch between them, because I want to know effectively or nominally, depending on what the question is. But if the A values are the same at the end of the day, then it also stands to reason that if A is the same as A, then P plus 1 plus I to the N is also basically exactly the same thing as 1 plus I over M to the Mn. Right? Because the amount after time must still equal the same thing. Right, can I simplify this formula a little bit? Help me simplify this. What can I do? Right, so I got P equals P. Great, now what? And let's just remember, well, whatever. Right, how do I do this? Let's do some basic math here. Right, I'm going to divide both sides by P. Right, thank you. P's gone. Now what can I do? Anybody? Right, we're going to root both sides by n. Root n, root n. Right, is there anything more I can do? Let's have a look. So now what do I have? I've got 1 plus I, which I told you was the effective nominal, the effective interest rate, equals, that bracket's still there, 1 plus I over m, and that m is still there. Oh, and that's the nominal interest rate. So now I've got my formula to decide to convert between the two. Okay, now you're supposed to memorize this formula in grade 11, that 1 plus I effective equals 1 plus I nominal over m to the power of m. But as you can see, if you just know both of these formulas and equate them, you can quite easily convert now between the two different interest rates. Okay, some very interesting thing. If you obviously, now what does it mean to compound monthly? You would divide by 12. If you were to compound quarterly, you would divide by 4. Compounded semi-annually, divide by 12. If you were to compound daily, which you can, which banks probably do anyway if you want to withdraw money, right? They will compound daily. You could technically compound hourly, per second. And if you wanted to compound infinitely, in other words, like every millisecond kind of thing, you end up finding Euler's constant, which is 2,7 something or whatever. And if you go and find Euler's constant, it's on your calculator. And anyway, so it does tend towards a number, even if you compound infinitely. I know, that was for free. You don't need to know that. Okay, great. Make sure you know how to convert between effective and nominal interest rate. It will definitely be there. Again, that formula, 1 plus I effective equals bracket 1 plus I nominal over m to the m. Right. The important thing as well, when you put a number there, immediately put it over there. Okay, good. So that's fairly straightforward. All right, what else do we have? Timelines. Okay. Let's start with a timeline situation. All right, so let's say I invest 50,000 bucks. All right, 50K at 12% compounded interest per annum monthly, right? 12%, let's just write this nicely. 12% per month. And then they always say compounded annually, okay? They always put that in there, just so it's per month, per year, compounded annually, or PA, per annum, right? But there's the per month thing that we're looking for. Right, I invest 50K at for 3 years. After 5 years, I take out 20,000 for a nice holiday. Right. Then, after 7 years, from the initial thing, after 7 years from the initial investment, after 7 years, I change to a different bank, change to new bank at 13.5% per month as well, compound annually, right? And then what do? I add 10,000 bucks after 9 years. It'll never be this long. How much at the end of 12? How much at the end of 12? After 12. After 12. Okay. There are 3 things I want to see on a timeline. Time, obviously, the interest rate, and the values. Okay, so here we go with our timeline. Are you ready? I'm going to be clever over here with my fancy little lines. Okay, here's my line. Okay, now usually the wording is sometimes strange. Right, we always start at T0. Nothing has happened with your money yet. Right, at the end, we've now got T10, right? Sorry, T12, they asked how much after 12 years. Just fix that nicely. Okay, now I want to go and find all my other significant times in there. Right, so I invest 50K, 12% for 3 years. After that should actually be off, whatever, it doesn't really matter. After, whatever, let's take that out. Invest 50K, 12%, right? After 5 years, great, after 5 years, term 5. Take out 20K. So there, I had 50K in here, and I'm going to minus 20K over here. Okay. Then after 7 years, okay, fine. After 7 years, term 7, I'm going to change the new bank. And then after 9 years, I'm going to put some more in that account. Fantastic. Right. So there's all my time limits. Now, and what happened at term 9? I added another 10K. Great. Now let's go and sort out the interest rates. So I've got my values, I've got my time, and now I need my interest rates. So 12% per month for 5 years. Okay, great. So there we go. There it is over there. Right. Oh, sorry. Oh, that's not true either, because the bank only changed after 7 years, isn't it? Right. So here we go. All the way up to 7. And there you go. And then the interest rate is going to change for that part over there. Great. What was the interest rate for 7 years? It was 12% for the first 7 years, right? 12% compounded monthly. Great. And then from 7 to 12, it was going to be at 13.5% also per month, compounded monthly. Okay, great. There's 3 marks to my timeline: my values, my time, and my interest rate. Like I said, you are unlikely to see so many transformations happening with money, but I want you to understand the concept here. There are 2 ways of doing this. Usually in grade 10, you were taught like the stop-start technique. What is that? And this is like the worst way you can possibly do this. Right, what is the stop-start technique? Well, we're going to invest 50K for 5 years. Stop. Minus the 20K. Great. Get that value. Invest for a further 2 years. Stop. Get that value. Invest for another 2 years. at 13.5% now. Stop. Get that value. Add 10K. Then we carry on going until we're at 12, and then we stop again. Now, that is very tedious, and it's going to take a very, very long time. So what do we do? I'm glad you asked. What we do is we run everything through the timeline. What does that mean? Well, remember, everybody has a turn to go right through the timeline. That's the whole point of them being on that timeline, right? Just like in life, everybody gets a turn to go through the timeline. So here we go. So what are we doing? We're working out the amount after interest. All right. So what's happening? Let's work with this 50,000. Right. That 50,000. Now, I want you to tell me the individual stories of each value that happens in this top line over here. So we're going to run that 50,000 right through the timeline. I know that there's minus 20K in there, and I know that there's 10K in there, but I'm only concerned about the 50,000. All right. Tell me about this 50,000. Well, have a look here. This 50,000 goes on for 7 years at 12% per month. Great. So 1 plus 12% over 12. You'll see I'm using the compound interest formula to the power of 12 times 7. Great. Now, I want you to think about it. If I now subbed in this value here, I am now exactly at this point that I want with my 50K. So if I had an answer there, what would I do? I would take that answer and invest it further, at another 13.5% for 12 months, or per 12 months, at 12 times 5, because now there's another 5 years to go from 7 to 12. And that now is the full story of the 50,000. Done with the 50,000. Great. Now, who else is in this timeline? The minus 20,000. Hi, minus 20,000. So we're going to add this, minus this 20,000 from the timeline. What's the problem with taking money out of an investment? You don't just lose that 20,000, you lose all the money that it came with. So now let's talk about this minus 20. Okay, well, that minus 20,000 could have been there. So that was a 12% account. Compounded monthly. Yeah, good. 12 times. Right. Now, how many years was this 20K not in that account for? Only for 2 years. Right. Now, again, I've got a value there. So it also loses, unfortunately, another 13.5% monthly, 12 times. And again, that's now for the last 5 years. Great. Haha, that's now the story of the 20K. But there's more to the story. There's this 10K over here. And this 10K comes in at the end of the session over here. Haha. So I'm now going to plus the 10,000. And that was in the account at 13.5% for 12 months. And again, for 12 times, and how many years? From 9 to 12 is 3 years. And so I just put my 3 in there. Right. Now you pick up a calculator. And what you do is, first, you put this blue part in on your calculator. And you push equals. And you're going to get an answer. Then you're going to push minus on your calculator immediately. You're just going to push minus. Once you push minus, you're going to have answer, and then you're going to have that, and then you're going to put that minus in there, and you're going to put that all other business out. Push equals again. Then you're going to add the 10,000, and you'll see that your answer will come up again, and you're going to add that 10,000. Then you're finally going to push your equals, and you're finally going to get a final answer. The reason we do it in a little bit of steps, there's actually not enough space at the top of your calculator. So one step at a time. Boom, boom, boom. And that is how we are going to do timelines. All right. So guys, timelines, fairly simple. You draw up your timeline and you run it through the timeline. Okay. Yeah, good. All right. Let's take another short break. And then when we come back, we'll practice questions. That is basically all the theory for finance. One more thing. Always one more thing. Sorry. I just want to show you quickly how to convert between currency. For some of you, this is like roll your eyes thing, but you'll be surprised how many people get this wrong. All right, let's have a look here. Let's say I've got rands to pounds, okay? And let's say I put this as 20 to 1. Which currency, in fact, I'm going to put another one down before you become a hero. There's pounds to dollars. So I'm going to go 181 to 2,41, whatever, okay? If I look at this one over here, right, this highlighted one, according to my ratio, which currency is stronger, the pound or the dollar, according to my ratio? Which one is stronger, the pound or the dollar? Yeah, you see now. Okay, let's have a look. If I look back, yeah, I know. If I look back at this blue one over here, right? If the rate now, what does this say? This is 20 rands will buy 1 pound. If you read it the other way, 1 pound will buy 20 rand. So obviously the pound is stronger because it takes less of them to buy more of them. There you go. So now if I look at this yellow one, what do we see? There are less pounds for the dollar. So the pound is going to be stronger because I need less of them to buy more of them. Okay, so good. There's one thing done and dusted. Okay, right. Now, again, let's just go rands. Let's just say dollars now, whatever. All right. If I go one, no, I won't go one. Hey, that'll, yeah, right. Right, where are we? Almost more than 18 rand, but whatever. All right, 18 to 1. Right. If I now ask, how many dollars can I buy? Sorry, how many rands can I buy for $5? What happened here? But what am I going to do now? How many rands can I buy for $5? Yeah, 90. Why? Well, remember, ratios are fractions. So what we do to the one side, we do to the other. Okay, you remember this from grade 8 and grade 9. I'm glad you remember this. Okay, right, let's make it a little bit harder now. Right, you need your calculators. Right, let's again go rands to dollars. Except this time now, I go 20,57 gives me, oh, hold on, I need a bigger number, just hold on. Right, let's just go 369 will buy me $152. Okay, right. I now want to know how many rands can I buy for $1,000? Okay, what do I do now? Now, a lot of you have got very clever formulas that, yeah, exactly. I was waiting for that. Yeah. So a lot of you got clever formula from vaguely remembering grade 8 and grade 9. I'm just worried when your methods let you down, what are you going to do? And that's why math needs to be instinctual, right? Now, yeah, good. All right. The reason being, I don't know how 152 becomes 1,000. I don't know. But how does 152 become 1? How does anything become 1? Through a good diet and meditation, you can become 1. No, in maths, how does anything become 1? You divide by itself, right? So in other words, good, we're going to divide by 152 to get the 1. Then how does the 1 become 1,000? We times by 1,000. And what you do to the one side, you do to the other. So that's what I'm going to do here. I'm going to divide by 152. I don't care what that answer is. Then I'm going to multiply by 1,000. And then I'm going to get what my answer is. And who can tell me what it is? For $1,000, I will get 2,427 Rand and 63 cents. Okay. Yeah, which is, yeah, right. But you can see, and also guys, look here, it's almost a 2 to 1. Right, so that's 300 and this is 150. So you can see it's kind of double, and you can see 1,000 to 2,000 also kind of double. All right, so whenever you are asked a currency question, set it up as a ratio, turn one side into 1 and then the number you need, and what you do to the one side you do to the other. Okay, great. All right, we're going to take a break. I will see you guys back here. Let's take a there. All right, here we go. So finance. Now, guys, I suggest that you do this with your whole paper. I sat with grade 12s yesterday and going through a paper, what to do when. And you start that with your algebra, like, okay, it's quadratic, make it equal 0, factorize. Okay, it's this, do this. All right. And the same thing with finance. Finance in grade 12 is usually one of your easier sections. Why? Just pick the right formula and sub into it. So that's all I want to do with you now. We're just going to pick the right formulas, and then you can do the math on your own time. All right, here we go. Number 1. 6.1a. A company bought machinery valued at 15,000. The depreciation is calculated at a rate of 12% per annum on a straight line basis. Calculate the value of the machinery at the end of 6 years. Great. Type the formula you're going to use in the chat column. Let's see. What's the formula? Good. Right. A will equal P1 minus I times N. It's linear. And there we go. The other thing I want to tell you now as well is even if it were reducing balance, for argument's sake, is never compounded monthly or anything like that. Okay. Depreciation is always effective. So you never need to worry about dividing by M for depreciation. Good. Right. So we're just going to sub and solve, and there's your 3 marks. Formula, substitution, answer. Great. Moving on. If you don't write the formula, okay, and this is also what my pet hates about teachers. If you did this, A equals 15,000, 1 minus 12% times 6, okay? First of all, are you allowed to use 12%? Yes, there's a percentage key on your calculator. If your teacher's forcing you to convert into decimals, go jump. You've got a percentage sign on your calculator, don't be a hero. Right. If you were to sub directly into the formula just like this, you are going to, well, in my opinion, and I'm a matric marker, you are going to get all 3 marks. Why? Because you substituted correctly. What formula is this? Oh, it is the decreasing straight line formula. So you're going to get your 2 marks anyway, and then obviously for your final answer, you're going to get your last mark. So guys, for me, rewriting formula is a massive waste of time. You don't have time to do that. Sub directly into the formula and be a hero. Okay, right, next one. 2,500 is deposited into a savings account at 15% interest per annum compounded monthly. Haha. What is the monthly nominal interest rate? You can tell me for 1 mark. What is the monthly nominal interest rate? For B. Careful, new question, Rotendo, but I know what you're trying to say. Right. Okay, right. Right. So there we go. 15%. Huh? Right. Why is that the nominal one? Because they told us 15% compounded monthly. Oh, yes. And the second it's compounded more often, that's nominal, numerous times. Right. So that's why that's only 1 mark. That answers simply 15%. Great. Determine the effective yearly interest rate. Remember what I told you, effective interest rate? It's annual. What's the formula? 1 plus I effective equals bracket 1 plus I nominal. Okay, cool. So we have got 15% over 12 to the 12. And now you can see that this I is your only unknown. So you simply work out that bracket minus 1, and then you've got I times by 100. Right, and that's 4 marks. For why, I don't know. But formula, I suppose, substitution, and then what? Answer times by 100, I don't know. But either way, super easy. All right, because we know what the formulas are. Right, then it says calculate the amount of money at the savings account at the end of 7 years. Well, again, all we're going to do now is take that 2,500 and we either use the effective or the nominal. I'm going to use the 15% over 12 for 12 times 7. All right, mathy. Right, last question. Well, not the last, right. Danelle takes out a loan of 550,000 in order to finance a new business. After 4 years, she expands and borrows a further 560,000. 3 years after that, she pays off the total debt in 1 payment. The interest rate of the loan was 18% per annum, compounded quarterly. Determine how much she owed. What is this question? What are you going to do here for C? A timeline, right? And you're just going to go 550,000, and I'm going to plus the 560,000. I'm going to add them because I want to add up all the debt. Okay, I'm not going to minus 550, minus 560. I know I'm borrowing, but we're going to add up the debt, changing the interest rate, and there you go. Okay. Right, now you can see what I was trying to explain earlier, the difference now between, what do you think this graph is trying to show? Before you even read this, what do you think this graph is showing? Don't even read it. What do you think this graph is showing? Good. Right. Linear versus reducing. I couldn't have said it any better. Very nice. Okay. We can see which one is the straight line depreciation. And this is what I was trying to explain earlier, is that in the long run, look at the exponential graph. In the long run, it actually won't depreciate as much as if it were a straight line balance. All right. Obviously, there is a point where they are equally worth something. All right. Tell me, how am I going to get, in fact, I can read it straight off the graph, can't I? But anyway, how do you think I could get this algebraically? How could I get this coordinate algebraically? Yeah, you'd equate the graphs. And you know, earlier I asked, what function is this? What function is this? Why do I keep on asking what function it is? Because everything in high school, all of it, can be expressed on a Cartesian plane. Why? Because we've always got an input and an output. All of it is functions. That's why it's always substitution. Input and output, always. Right. In this case, it would be A and P in terms of time, which is N. Okay. Okay, fair enough. All right, moving on. All right, and again, guys, I just want you to see that it's the same questions all the time. All right, there are only 3 things that you're going to be asked to do: is depreciate, make a timeline, convert between nominal and effective, and there you go.